All right. Good morning. It is CDK day. Who is excited? Hey, I'm seeing a lot of chat going on out there. Folks are excited. My name is Eric Johnson. I want you to see my shirt. I'm pretty proud of this. Matt, tell them who you are.
Hey, everybody. My name is Matthew Bonig. I've got a shirt as well. In fact, if anybody can post in comments about what this is a reference to, then I'll make sure you get a pancake sticker sent to you in the mail.
I already tried, and I could not for the life of me see that.
It's a really deep reference, yes. But hey, we're really glad to have you here today. We are super excited. We had over 3,000 people signed up today for CDK Day, which is amazing.
3,000.
So thank you everybody for coming today. We really appreciate it. We hope we got some really good content for you.
All right, so let's get started. So first of all, yes, I already see a comment. It's OMG Eric, and I think what they're saying is, what is he doing on this CDK day? So you're right. Most of the time you see me with Sam. I am a huge Sam fan, and I'm going to be really honest. I can't even spell CDK, but I want to learn it. I'm very excited about it. So I was excited to get to host this, and the reason I'm hosting this is if you're a newbie to CDK, I'm going to ask the questions you're thinking. One, how do you spell CDK? One, how do you do things? But normally, like I said, I am a developer advocate for serverless on AWS. And guess what? Matt, can you build serverless with CDK?
Absolutely. In fact, it works really well for building serverless.
Yes, it does. And I've seen a lot of really cool things coming out. So with that, let's kind of get started. So let's take care of some of the housekeeping here. So first of all, Matt, why don't you jump in?
Yeah. So first off, if you haven't joined it already, we have got a Slack channel for the CDK. Go ahead and join it on this link right here. And in that Slack channel, we're going to be having conversations all day. Each of the talks will have their own breakout room, so you can join in the discussion there. If it's a recorded discussion, we've got a lot of moderators there to take questions and things like that. We do have a code of conduct for the entire day for our Slack channel. It's going to be available right here on this cdk.com/COC. Please take a look at that. If you have any problems, if anybody isn't being kind, please go ahead and just submit a report over to this right here, this email report at cdk.dev. We want everyone to have a really good time today, and we don't want anyone to be attacked or harassed. So please adhere to that. Finally, we're going to have a Q&A session during the lunch break with a round table of about 4 or 5 people. So if you have any questions about the CDK, the CDKs, or the Terraform CDK, please ask those questions within the Slack channels. And when we get to that lunch breakout, we're going to go ahead and try to get those answered for you.
Is CDKs. I have to ask, what is CDKs? And I don't want you to go into it, but what is that? I hear CDKs. Is that KATES?
That is the CDK API built for Kubernetes, so that you can go ahead and use the same construct API model for building your Kubernetes resources.
All right. Okay. And we're going to cover some of the others. I got to be honest, again, being the newbie, I thought CDK was just AWS, but apparently not the case. So and we're hearing from some different folks in other clouds, right? And and it's not all going to be SAM from what I've learned. And so, there's probably going to be very little SAM in this. That's okay. I'll bring the SAM. But yeah, that's really exciting because CDK, so help me list it out. And you're probably going to cover this later, but you're talking CDK, obviously the AWS CDK. Yep. So Matt, what does CDK stand for? Let's get real basic for a minute.
Oh yeah, real basic. Cloud Development Kit.
Okay. All righty. Okay. All right, so it's Cloud Development Kit. Okay, I can do that. So now I can spell that. Okay. So second thing, what are the different CDKs that you can do?
Well, we've got the original AWS Cloud Development Kit, or CDK, and that's what we're going to be largely talking about today. But we've also took that excellent programming model, excellent representation and abstraction of your infrastructure as code, And within the last few months, we've seen two major projects come out of it, the CDKs for Kubernetes and the Terraform CDK. But we'll have some presentations on both of those today. And we've got a really cool one at the end, which is the CDK for Azure prototyping with a gentleman from Microsoft. So stay tuned for that at the very end. We're going to be also seeing one for Microsoft's Azure platform, which is awesome. And I have a feeling we're probably going to see more of these coming out through the future.
I would imagine it's an interesting concept, and I know we're going to go deeper into it. But when people ask me, what is the CDK? It's this. Well, I'll let you cover it. I know you kind of got a 101 coming up, so I'm going to let you cover that then. But I want to introduce somebody, okay? And I'm gonna pull him in real quick. Hey, there's Elad. Hey, Elad, welcome.
Hey guys. Hi.
This coming to us from Tel Aviv. What time is it there, Elad?
It's 5 p.m. Not too bad.
Oh yeah, that's not. Yeah, I had to get up at
the earliest I've met with people.
Okay. All right. All right. So this is Elad Ben-Israel. He is the principal engineer for the AWS CDK team. So I welcome you. And yeah, tell us more about what's going on with CDK.
So yeah, hi. It's great to be here. It's very exciting, to be honest. See so much people interested in this project, and this day organized by the community is probably the most fulfilling thing that we can expect from something like the AWS CDK project. I'm a principal engineer at AWS. I've been working on the CDK project for the past 3.5 years almost. So basically started the project very early as a prototype in Amazon.com as part of the team that worked on Amazon Search, the search box that you see in the Amazon.com website. And what we did there is that we had this big data streaming service that we needed to build to inform the search index when new products are being ordered or viewed, so that the search index can be more efficient. And we use Kinesis and DynamoDB and Lambda and all the good stuff that AWS has. And obviously we also use CloudFormation because we needed to deploy this into multiple regions with development accounts, integration accounts, testing accounts, and stuff like that. A very classic AWS type, Amazon service. And very quickly we realized that writing all this configuration in JSON and big JSON files that grew larger and larger and involved, and there's a lot of relationships between the resources, it's just not maintainable. It's not the right tool for being able to model all this complexity and test it in isolation. And so being developers coming from the software development space, we knew that there are better tools, and general purpose programming languages, object orientation are great tools to model these things. And so what we did is we created this library, internal library in Java. We use Java in this project to be able to express those abstractions in code and generate the CloudFormation. We just thought we want to treat CloudFormation as the assembly language, as the intermediate language that eventually goes off and does the heavy lifting of provisioning the resources. But when I actually define my application, I want to be able to use imperative structures like for loops and if statements and create, and express ideas like my ingestion pipeline or my store layer, things like that we do all the time in software. And this proved very, very successful. It was really fun to work on this project. And what we did is basically Amazon has this great culture of internal entrepreneurship. What does that say?
That said serverless for everyone. They were asking me where the Dr. Pepper was. There's the Diet Dr. Pepper. I wouldn't be without it. I am sorry for throwing you off your game there.
No worries.
Okay.
And so I wrote this press release. Amazon has this format called press release. It's pretty well known, and it's actually a really magical process. And basically what you do is you write about the future. You kind of write like a science fiction press release, something that will happen within 2 years or 1 year or 3 years. And so it's as if Amazon had released this as a public product within a year. And I started touring Amazon and showing this press release to leaders around the company alongside this real world, large scale project. And these two things were very convincing, right? Because we had a really strong use case, we had a really strong problem and really strong solution to the problem. And quite quickly, we got funding to get started. And Amazon's very organic. So we actually hired someone from the Netherlands who built another internal tool that did something very similar. It's very chaotic at Amazon. Eric, I know you're probably familiar. So it's all chaos. It's basically embracing the chaos.
Organized chaos, that's right, yes.
Chaos. Yeah. We accidentally found this guy in the Netherlands, so we hired him and started working on the project. And I guess the rest of his history. That's how the CDK started. It's from real world problems, right? From real world pain.
So that's quite a story to bring you to, and I know exactly what you're talking about. Yeah, I've written a few PR FAQs is what we call them. And that's a process. So going back on that, so in the PRFAQ process, and I'm not going to expose all that, but some of the things we have to do is we have to answer questions. What do we think people are going to ask us? What were some of the questions you thought, okay, here's what they're going to ask us, and what are people asking you? I'm curious about that.
I think the biggest question that really was a really hard question, especially given our prototype was Java. Amazon is in many ways a Java shop, or at least big parts of it, especially Amazon.com.
I'm working on that.
Yeah, and so I think the biggest question was like, are we going to release this in Java? Are we going to force everybody to use Java in order to define their infrastructure? And the answer is no, right? We're customer obsessed. We want to be where developers are. We want to bring the things to their comfort zone. And so I think that was the biggest question, and it actually took us some time to come up with JSII, which is actually a separate technology that's heavily used by the AWS CDK and by all other CDKs, that allows us to write the CDK in one language, in TypeScript, and vend it to multiple programming languages. It's quite unique and very special. Obviously, it takes some interesting trade-offs because of the nature of this technology. But I think that was actually the biggest kind of question that people asked. And, we had to go back to the drawing board because, they told us, we're not going to be able to fund something like that at the scale of AWS, offering high-level APIs for all AWS services and only apply to people who use Java or TypeScript or Node or Python.
Right. I'm sorry. Go ahead. I interrupted you.
No, so I think this was definitely an interesting question, and was a very interesting challenge up from the day one of the project. Like, we couldn't start the project without having a solution, and so we prototyped some ideas and came up with the process, the engine for JSII, or the idea behind JSII, and we proved that it's possible. Obviously, it took a year longer than I wanted it to take. I was ready to announce that could reinvent, 2 months later. But I was young and stupid back then. And now I'm just older and stupid.
Well, I don't know if you saw earlier, but there are some folks who think you're a mad scientist, is what that message said. So, all right. So something happened yesterday that was pretty cool. Tell us about it.
Yeah, it was actually a very pleasant coincidence. We knew this is going to happen. We couldn't really share it with with everybody, but we had the AWS Summit, the American Summit today, and Werner Vogels in the keynote spent about 20 minutes talking about the origins of the CDK. And so if you're interested in learning more about the story, there's a little link there. And you can find it quite easily. And they made an incredible job explaining the origin of the CDK, and actually the idea behind it is beautiful animations and stuff. So highly recommended, and it's very nice to see that.
So tell us, we've got the AWS CDK. We've seen the CDK project come out recently, and that's something that you guys really spearheaded internally, correct?
Yeah, I think even before we GA'd the CDK, it was in developer preview for I think about 6 months. And during that developer preview stage, we saw lots of traction, we saw lots of interest, and we learned about the technology, right? Like, it's not that we knew everything. It's a very organic process. The software designs itself in a sense, and at some point we were like, this must apply to other domains. This idea of being able to use imperative, general purpose, strongly typed APIs to define configuration that then goes into a declarative system, right? Like, it basically gives you the best of both worlds in a way. It should apply to other domains, and Kubernetes is very popular and was very popular already back then. And so we kind of set our eyes on that, and we try to find partners to build this thing, to kind of prototype this idea of CDK for Kubernetes with. I think it took about 3-4 months before I met the senior product manager for EKS at the GA of the AWS CDK. And we literally accidentally met at a bar, at a rooftop bar in New York. And he approached me and he said, "We have to build a CDK for Kubernetes." And I was like, "Yes, we do." And then we partnered up. It took 6 months or something to get that kick that off, especially because CDK for Kubernetes, as opposed to almost every AWS initiative in the space, is completely open source and completely non-AWS specific. It's not related to EKS. It's not related to AWS resources. It's pure Kubernetes. And so it took us some time to find the right leaders at Amazon that really understood that this is the right thing to do in the Kubernetes space. And so it happened that we basically looked at this project that started extracting the lower level building blocks from the AWS CDK into open source libraries. So we had JSI already open sourced, and we extracted the construct base class, which is at the core of all CDKs at this point, and a few other modules. And then we took those modules and connected them together and created the Kubernetes CDK. And it's also very early in this project, but I'm super excited by it. I also think it's going to be incredibly valuable to users.
I agree.
Right.
I personally agree.
Yep. So Elad, we're going to be hearing from you a little later, right?
Yeah, I'm going to talk about another CDK project that I'm playing.
All right. Well, we're going to bring in someone else here. We're going to bring in Mishra, and Elad. We'll see you a little later.
Thanks a lot.
So, all right.
Thank you, guys.
Bye. Hey, Mishra, welcome. Thanks for joining us. I'm pretty excited to have you here. Tell us who you are and what you're doing.
Yeah, I'm really excited to be here. My name is Mishra. I'm the technical advisor to the CTO at HashiCorp. So I work in the office of CTO, and I get to talk about CDK for Terraform, which comes from a collaboration between AWS and HashiCorp. So it's been a really exciting few months for us.
Awesome. Okay. So tell us about, so Terraform, and this was new to me. So tell us about, and I've got your screen up here. Tell us about this integration.
Yeah, I think I'll kind of give some kind of the human side to it. I'm really happy that Elad was on the call, because we collaborated with Elad for probably the early months of the project. And then the AWS CDK team was super supportive throughout this. So the way this project began was at AWS reInvent, when I think Elad and team approached us. And this was, I don't know where exactly it was in the event, but it was during the reInvent days when we could actually do conferences in person.
Those were the days.
I know, right?
Yeah.
And then I heard reInvent is virtual this year, so that's interesting.
It is.
So we met up, and then the Office of CTO got involved, which is basically my team, and then and a few other teams at HashiCorp, like the community teams and so on. And we started kind of working on the proof of concept. Elad already had a proof of concept up, so we kind of wanted to prove that and improved it over time, and then basically we're able to take that proof of concept and elaborate on it. And then Sebastian, who created TerraStack. I don't know, in the CDK community, you might know Sebastian online on GitHub and Twitter. He does a lot of work around CDK and also runs a newsletter and so on. So yeah, Sebastian was working on this project, so I convinced him to work on the CDK for Terraform project, which anyway we were, kind of doing with the CDK team directly, and he immediately got involved. And yeah, it was really exciting to kind of just work on it together as a community. So far, as you can see in the picture, we support of course HCL, JSON, and Kubernetes CRDs in Terraform already. You can kind of treat Terraform as a platform. And then CDK for Terraform is just another interface to interacting with Terraform, and you get access to all of the 200 providers. So that's important to know that you can use it for like AWS, Azure, Google, anything you like that Terraform supports.
That's interesting. Yeah, so that gives Matt, go ahead. I didn't mean to talk over you.
Yeah, so this means that, one of the downsides to the CDK when it came out, people complained was, this is only for AWS. Well, now we've got the same programming model, the same constructs, the same APIs. Now we can do that for all the stuff that Terraform hits.
Absolutely, yes. Awesome. That's very exciting. I think the same constructs that you're familiar with on the AWS CDK side, you can use in CDK for Terraform. But one important distinction here is that AWS CDK, CDK K8s, and CDK for Terraform are independent projects. They all have different CLIs, and currently they don't interop. But I think in the future we want to make them interop, and that's kind of the future we all are looking towards, hopefully, as we work towards this independently in the projects.
Awesome. Looking forward to seeing it.
All right, and we're posting some links here. If you want to chat about CDKTF, you can obviously CDK.TF discuss, and then you can learn more at the CDK.TF.learn or /learn whatever /. All right, Matt, I think it's time. I think we need to get rolling. We've done a lot of yammering here, but I think it's time to get started with our first presentation, which is actually going to be you yourself. So you're
total coincidence. I didn't come up with the schedule myself, so don't anyone think that this is an ego thing. Quick reminder for everybody: if you have any discussions or any questions during any of the talks today, there are the Slack channels that you can talk in. I'm going to go hop in the one right now that is for me. That is the Slack channel for my talk. I'll be answering questions along the way and posting a few links. So we'll see you in a minute.
All righty. We'll see you then.
Welcome, everybody. Thank you for coming today to CDK Day. This is the CDK's talk, or how you can use constructs to build out your Kubernetes resources. My name is Matthew Bonig. This is going to be a lightning talk. This is going to be very quick. I'm going to breeze through a lot of things. There are blog articles and code samples for all of it, and I will be posting links to those in the Slack channel. So let's get started with a little bit of background. The AWS CDK was released last year as an alternative to CloudFormation in creating infrastructure as code. It allows you to define your infrastructure using the idea of a construct. And a construct may be something as small as an S3 bucket, or it could be an entire application stack. You wire these constructs together. It doesn't really matter how big or how small they are, the API still works the same regardless. So in this case, with the AWS CDK, we're going to start off with L1 constructs that are generated from the CloudFormation spec and are one-to-one mapping with those things. You never usually deal with CloudFormation L1 constructs directly, so we always deal with L2 constructs in most situations. And these are wrappers around the L1 constructs. They give us just a nicer interface to work with, some helper functions, things that take care of common security concerns or wiring things together in a nice way. And then from those L2 constructs, you can build an L3 construct, which combines multiple L2 constructs together to build out an entire, sort of microservice or application stack. This is an example of a simple GraphQL service. This image comes courtesy of the CDK Patterns project. If you're not familiar with them, I highly recommend you check them out. They take common serverless architecture patterns and create CDK examples for you to learn from. In this case, this would be a GraphQL service that's made up of an AppSync resource, an AWS Lambda, and a DynamoDB. So this would be packaged into a construct that could easily be distributed out to your teams, and they wouldn't have to know the internal workings of these things. They just know, okay, this will give me a GraphQL service on AWS serverless. So how does this relate to Kubernetes and infrastructure as code? Well, from this, Kubernetes already has actually infrastructure as code in the form of manifest files. But manifest files are very flat, they're very static, they're very easy to read, but they're not very reusable, and they're not very dry. So from that, you go on to Helm charts, and Helm charts solve some of the problems with that, but they introduce their own problems too along the way. This is all using a standard YAML format with Go templating along the way. And if you're not familiar with Go, you'll probably have to learn a lot of syntax along the way. But then there are some things in here that are just sort of annoying that you have to concern yourself with. Things like calling specific to YAML functions so that a variable that was passed in gets rendered out as YAML. And then because it's YAML and it's white space dependent, you have to make sure that indentation is really correct. And these things can be very painful to maintain over time. They're very large. They don't solve common problems like good refactoring or good reuse of code. Now, when it comes to testing, you're kind of limited in this case. You can do a very simple test by running a Helm template command, which will take that Helm chart and try to render the YAML from it. If it succeeds, then great, you know you have syntactically correct YAML and a Helm chart, but it doesn't really do any functional testing to make sure that a variable provided over here ends up in the right place in the YAML file. So the other option is to go through automated testing, but these automated tests can be very hard to work up, and they require running Kubernetes cluster because they're ultimately integration tests. So at the end, you end up with these Helm charts that are really hard to read, they're really hard to change, hard to test, and which means they're really, really hard to maintain long term. So how do constructs aim to fix this? Well, we'll start off with a deployment construct here, which is, this is coming from the CDK8 Plus library. It is a L2 construct, which I just provide over kind of our common replica count containers, those sorts of things that you're familiar with creating a deployment. And then it gets this expose function. And internally, when I call this expose, it'll create a service for me that's automatically wired up with the deployment and everything. So once I have all these constructs built, I pass it to a synthesize routine, which will then spit out a bunch of YAML that I can then hand over to Kubernetes using a kubectl command or GitOps or whatever your normal CI/CD pipeline is for these types of things. So with CDKs, we go ahead and L1 constructs are generated from the Kubernetes resources or from CRDs that you provide. L2 constructs you can either create or you can leverage CDKs plus L2 constructs from that library to build out your L3 constructs, which might be entire application stacks. This is an example of a MERN chart that I built this year for a Kubernetes cluster that I mentioned that has like 3 or 4 running MERN applications in it. So in this case, this chart will create me an issuer for all my certificates. It'll create an ingress for my public accessibility. And then I've got a deployment and a service, and these things all get wired together. And at the end, it spits out all of this YAML that I can just then kubectl apply it to my Kubernetes cluster. And every time that I run that synthesize routine, I'll hand over different variables and it'll spit out slightly different YAML along the way. So what are the benefits of this? Why would you really want to do this? Well, one of the benefits of the constructs and CDKs is that they're multilingual. You can write these in Java, TypeScript to JavaScript, or Python. And that's actually a really big deal because normally your application developers are the ones who are probably going to be maintaining these charts in a lot of situations. And there aren't still a lot of Go developers out there. And a lot of these situations that I've run into, there's still Python and Java developers. So when a Python and Java or TypeScript developer has to context switch over into Golang to work up these templating languages and things, it can be very painful. So being able to write this in the languages that I'm already familiar with is a big boon to that productivity and a big benefit to it. But also, this is all unit testable. It's very easy for me to write a unit test that verifies that my construct is generating what I want it to generate, and I don't need a Kubernetes resource cluster to actually verify any of that. And this is all just wonderful, fantastic magic that we've been accustomed to on the AWS CDK and that is now available with Kubernetes in the CDKs project. So let's say I've convinced you. Let's say you want to start adopting this. How would you actually go about doing it? Well, it's actually not too bad thanks to the fact that Kubernetes is naturally infrastructure as code already with manifests. First thing we're going to do is we're going to import any of the resource definitions or CRDs that are important to us and our particular cluster. Then I'm going to start snapshotting out the resources that already exist in that cluster and save those off as JSON files. I'm going to write unit tests that leverage those snapshots to verify that the constructs I'm about to build match those existing resources. And then I go and I implement my constructs. So defining those imports is really simple. There's a file within the CDK's project in which I specify that I want to pull in the standard Kubernetes resource definitions. I could also version tag this with just an @1.14.0, so I can pull in specific versions of those resource definitions. I can also point it at publicly available CRDs, or I can point it at CRDs which I have defined ourselves as an organization. Once these are defined as these imports, all of those L1 constructs will get generated in the CDK's project, and you can leverage them to continue building out constructs. As far as getting snapshots, it's really simple. You just go to kubectl and you ask it for the JSON definition of a particular resource, and then you save that over into a snapshot file. The unit test then just reads in that snapshot and verifies that the constructs and the charts that you've been creating in the CDKs match what you've already got, and then you go implementing with your TDD approach. And then you just repeat that snapshot and unit test and implementation process for each of the resources that you have in your particular application: ingress, deployment, service, so on and so forth. Now, this is all great and everything, but the CDKs and CDKs Plus are technically still in alpha. So a little caution in adopting them. They've learned a lot from the AWS CDK, and it is a fairly stable API right now. You're not going to see any major changes, but it is still alpha and it's a preview release, so be careful with it. Don't expect to be replacing all of your infrastructure as code with the CDKs right away. But I do recommend, if you're using Kubernetes, give it a look, see if it's going to fit nicely into your organization, if you're going to benefit from these things that we've talked about. So that's it. I'm going to be available all day in Q&A on the Slack channel. If you have any questions, please feel free to reach out to me there, or you can always DM me as well. Thank you again for coming today. I hope you have a great day at CDK Day, and I'll.
All right. Merrick, you seem to be muted. You want to unmute there?
Yeah, that's right. Now you can hear me, I hope. Hey, everyone. Thanks again for tuning in to CDK Day. And thanks also, Matt, for a super interesting talk. You haven't seen me yet, so maybe I'll very briefly introduce myself. My name is Marek. I'm a serverless solution architect at AWS and also one of your hosts today. And actually, we're here to announce very quickly that Tatenda Gibson will be the next speaker. He will be talking about CDK 101. So he will actually give you a bit of an overview of, what are the various deployment frameworks on to deploy your applications. So I suggest we switch over right to that presentation, and you'll see me and Eric in a bit for further information as well. So enjoy the talk.
Here we go.
Hi, everyone. I hope everyone is well. Thank you for joining me for this session. I'll be speaking briefly on AWS Cloud Development Toolkit. I think that is a mouthful, so I'm just going to call it CDK throughout this whole session. So I've been building on AWS and working with AWS services for over a year now. And I'm a huge serverless fan. I'll speak briefly about that in a moment. So CDK is actually a huge topic. It's not something I can talk about like in 10 minutes, but since this is a lightning talk, let's see what I can do. So a few things that we are going to go through. An overview, why CDK, a quick comparison with SAM, and then I'll share some few steps. So I'll assume that if you're already building on AWS or any other cloud provider, you've already adopted some form of infrastructure as code. The most popular frameworks that you've sort of been the standard have been CloudFormation, which I think is getting slightly overtaken by HashiCorp's Terraform. I know it's opinionated and stuff. When I started building on AWS, I was probably doing what almost everyone getting started does, like by clicking around the console to get resources deployed and stuff, right? I'm saying the word stuff a lot. However, due to the fact that this can be very tedious to carry out repetitious tasks, and you might easily run into a lot of configuration drifts, I opted and ended up using CloudFormation. Then later on, I moved on to SAM, the serverless application model. I'll briefly hint on what this is for those that do not know. Then recently, that's when I started using CDK. So CDK was released in 2019 by AWS. It is an open source multi-language framework for modeling and defining your cloud infrastructure using your favorite programming language, or a programming language that you are familiar with, if I might say. However, currently it is generally available in Java, script, TypeScript, Python, Java, as well as .NET or C#. Okay, I think that is straightforward. Why CDK? Well, I think my first point is probably going to get me in trouble, but CloudFormation equal to pain. Well, I think this is probably one of the primary reasons why CDK has become popular very late. I think the fact that it's sometimes very difficult to work with CloudFormation is what has led to the genesis of CDK as a possible successor of CDK, and that's in quote. Working with CloudFormation, I think it's great if you're working with a small set of services, with a small team, or as an individual developer. But CDK CloudFormation, I mean, heavily relies on markup configuration with either JSON or YAML. And if these files become large, it's very difficult to manage and share across teams. And not to mention, there's absolutely zero abstraction, or zero to nothing in terms of abstraction with CloudFormation. CDK accelerates your onboarding into AWS. I think since CDK uses a familiar programming language like common languages like JavaScript, Python, and TypeScript, etc., it's a lot easier for developers or even aspiring devs to grasp concepts as it's just code. I know if you're just maybe getting started with AWS, these things can be a bit hard, especially like figuring out the services. There's like a gazillion services there, and at the same time you have to go out and learn CloudFormation or HCL, which have a steep learning curve, if I might say. It also gives you the ability to define your resources at a higher level of abstraction using constructs. I'll explain this in the next slide. You'll see what I mean. Okay, so here is a basic outline of a CDK application. I just picked off this diagram of this link here from the documentation. So like I mentioned construct before, there are three types of constructs, basically low-level constructs, high-level constructs, CDK pattern constructs. I don't have time to really go through them all, but the general idea is that constructs are just basic building blocks of CDK application, and they can represent a single resource, for example, an SQSCA or a Lambda. So this diagram basically shows us how CDK in action works. I would have opted for a demo, but time does not allow, right? So we move on to stakes. Stake is just a basic unit of deployment or resources within the scope of a stakes, either directly or indirectly provisioned as a single unit, right? And then the app, the application itself. Again, here, as I mentioned, the idea is that the stakes go on to make up the app. So this diagram here really is kind of an outline of the resource hierarchy of CDK, for CDK application. So after you write your application logic code here to define your resources and run a command like CDK deploy, CDK goes out to synthesize this to a CloudFormation template, and then CloudFormation goes out to build and deploy your resources, right? So you're taking advantage of your favorite programming language as well as still getting power of CloudFormation as a provisioning engine. So here is just a quick comparison with SAM. Like I said, I'll talk about SAM. Well, the idea with SAM is that SAM is just an additional layer of abstraction on top of CloudFormation that enables you to accomplish more with a fewer lines of code. Unlike like CloudFormation, it makes a lot of decisions on your behalf, and I think it works best for serverless application that don't follow common patterns. If I might say. Actually, these common patterns might be a Lambda, API gateway, DynamoDB, etc. It also lets you test your application locally using the same CLI, which mirrors Lambda execution environment. So just basically YAML and JSON. I think I've explained this slide basically. So here's some sample code just to compare the two. Here's the same template here. It's basically going out to create an API gateway and a Lambda function. It's not that complicated, but it's a bit easy. But what I want you to show you is this VPC. This is like my favorite CDK construct deploy, because just with this one line, it goes to generate about 200 plus lines of CloudFormation. To create a VPC using CDK, you only need like to initialize your project, and then this one line of code goes on to create resources like the VPC, public subnets, route tables, internet gateway, and NAT gateway, and probably other like less exciting stuff, right? Here's an example of creating a DynamoDB with SAM. SAM, you just need to go and write this one line. It's quite simple and straightforward. Whereas with CDK, you would need to go and write out all this code. So I think CDK is a huge leap in the infrastructure as code paradigm. Being able to test and source control your infrastructure, not to say that it's the panacea of all your infrastructure as code problems, but I think it quite really excels in deploying multiple services that need to communicate with one another, like a cluster, containers, etc. If maybe you're building serverless application, perhaps I would say maybe go for SAM. It's a good choice, in my own opinion. So far, I really can't wait to see what innovations are coming to CDK, considering how rapid the community is growing. So to sum up, I wrote a quick article here on how to build an ECS cluster, which I think is more detailed, and I explained a few things in detail here more. Here's the link here. I'll try to get one of the organizers to share this in the chat section. Besides that, you can find me here at @tt__m. If you want to chat on Twitter, give me feedback, questions, or anything. Thank you.
All right. Elad, welcome back.
Thank you. How are you?
We are good. So next up, first of all, Tina, thank you so much. That was awesome. Great intro and a great 101 for people just kind of getting involved there. In our next session, Elad, we'll welcome you back. Quick 10-second summary. What are you going to be talking about?
I'm going to talk about a personal open source project of mine that I've been hacking on called Projen. And it's a CDK for software projects.
Okay. And it's called Project?
Projen.
Projen. Okay. That makes more sense. Okay. All right. Well, with that, I'm going to turn it over to you, and I'm going to bow out.
Thank you. Thanks. Hi again. So super excited to be here. And I thought it'd be this CDK day is a good opportunity to talk a little bit about this little side project that I've been working on called Projen. And I'd like to think of it as a CDK for software projects. And let me tell you what I mean by that. Modern software projects utilize a tremendous amount of tools. And actually, this list is growing every day when the bar is getting higher and higher when people want to build high-quality software. If we take a modern TypeScript project, for example, you would need NPM and package.json file to configure your NPM information. You need to configure your compiler with AWS Config. You have a bunch of dependencies with different types. There's a linter configuration and a rule set that you choose, unit testing framework like Jest, for example, coverage setup, version bumps, change logs, CI builds, automated releases, security patching, license files, NPM workflow scripts, et cetera, et cetera, et cetera. So if you or me, like when you create new projects, you want to actually get started, off the ground with a high quality environment. And so what I do is maybe go to a recent project that I worked on and copy and paste and clone my repo and tweak a few things and then get going with my new project. The art in this world is what people call templating or scaffolding tools or generators. There's dozens of them. YAML, React App, SAO, Webpack CLI, Mango, Risk, Plop. There's a new one every day. The problem with this approach, and it's actually a very similar situation to what we've seen with AWS CloudFormation when we started the CDK and with Kubernetes, and is that this is a one-off process. When you generate your project, when you create a new project, when you call create React app or clone a repo with Kubernetes manifest, you end up with a bunch of configuration that you didn't write, but you now own. And in software, we call this a leaky abstraction, because basically the surface area, the API that you need to work against is all of these configuration files. And each configuration file has its own style and format and quality level. And so Projen takes the CDK approach to this problem and quickly uses general programming, JavaScript or TypeScript. It's actually written in JSI, so you can use any of the JSI program. We will be able to use any of the JSI languages in the future. This example is a basic TypeScript project. And you see that it has this opinionated sensible defaults, which is something that most CDKs share. All I need to specify is the name of the project, and then all those features that you saw on 2 slides ago, you're going to get them for free just by instantiating a TypeScript class. And you see this looks like a CDK program, right? Like it's kind of like the app for a CDK program. You create the app, and then you call synth, and it synthesizes something for you. In the case of Projen, it will synthesize project configuration files. And obviously, you have rich API. So you can go and use your IDE and see the various options that you have in your TypeScript project. And so now your surface area is not all of those configuration files. It's a class, an object-oriented class with properties and methods and initialization process and a rigorous workflow around it. So not only this is a strongly typed class, it can be inherited from and extended. And so, for example, a TypeScript project is a node project, and a node project is a base project. And so you can use inheritance, so you don't have to duplicate the logic. And so once I implement some node project, it automatically applies to all TypeScript projects. You can use composition and for loops and if statements and strongly typed APIs and compiler support. And the most important thing, and I think this is, again, it's the same thing that we saw in Kubernetes and in AWS CDK, you can actually take updates. And so if someone finds a bug in Node project and submits submits a fix to that bug, and we release a new version of Projen, all the projects that are using Projen can update Projen and automatically take the update. They don't have to go back to the original template and understand, oh, there was a security issue in this template. Now I need to apply it to like 100 different repos across the universe. Okay, let's see a demo. I think that's going to be the easiest way to explain this. I'm going to show you how to create an AWS CDK construct library using Projen. This is the class hierarchy behind the scenes, so you get a mental model of what I'm creating. And so it's a pretty high-level project type. A CDK construct library is a JSII project. If you guys don't know what JSII is, that's a technology that we use in the CDK to vend it to multiple programming languages. And so there's some setup around publishing to multiple package managers and stuff like that that Projen does for you. And it's a TypeScript project and a Node project and a project and so forth. Okay, let's just see if this works. I actually had some trouble with my machine earlier, so I hope everything's going to work. This is a live demo, actually. Okay, we're going to take an example of a secure bucket, the simplest construct I can think of. Super not interesting. So I'll start by creating a directory with a Git repo. And I'm going to pop it in my IDE. It's completely empty. And so first thing I'm going to do is I'm going to initialize my project. And so Projen has a CLI like all CDKs. Projen new is what you use to initialize new projects. And you see that it shows you the different project types that are currently supported. And I want to add as many project types actually baked into Projen, so it's like batteries included type experience. So you can just like do Projen new and you get the project that you want. But you can actually bring in your own project types, obviously. So I want AWS CDK Construct, and I'm going to run it with no synth. It will automatically synthesize, but I actually wanted to show you the steps. And so if I run it with no synths, you see that it basically just created a single file for me called Projen RC. And it bootstrapped my project, Projen RC, with some required fields. Because an AWS CDK construct library has some requirements, as opposed to a TypeScript project which only requires a name. I need the author information for JSII publishing. I need to know which CDK version I'm targeting. And I need to know the repository, again, for JSII stuff. So this is basically the minimal AWS CDK construct library project. And now if I call synth, and synth is basically just running Projen, and that's the workflow. You basically modify this file and then run Projen again. You see that I suddenly get all these files. And I don't really know what these files are, right? Like as I said earlier. But the nice thing about this is that contrary to the scaffolding approach or the templating approach, these files are actually read-only. I can't change them. Projen doesn't allow you to change those files directly because there are an implementation detail of the project. And so if I want to modify these files or update these files, I basically have to go through the formal API. And like all CDKs, Projen also has escape hatches. So if you end up in this situation with your face in the wall and you have to actually change something that was not supported, then you can use the escape hatches to change these files directly. But on the outset, we have a rich API for these files. What else do we get here? Just out of the box, you see, I haven't really configured anything. I have a GitHub workflow for building my project. So it automatically builds every time someone submits a pull request or manually. I have a release workflow that publishes my stuff to NPM by default. You see, this is the only target that I get by default. I have dependent-bot configuration. I have an ESLint configuration. I have Mergeify configuration, which is this really awesome GitHub tool that allows you to automatically merge approved pull requests with sensible, opinionated defaults. I've got a git ignore and an npm ignore file. Those are harder to get right, to be honest. And we actually had some quirky AWS CDK patch releases that were caused by misconfigured npm ignore files. So no touching npm ignore files anymore. And you see that all these files are read-only, and all these files is this generated by Projen signature to make sure that you understand that you're not expected to edit them manually. You are going to check them into your repo, so you get kind of like an idiomatic experience in terms of like viewing the repo, and you can also see some stuff like diffing changes. Let me show you. Okay, I'm going to add all those files to Git because I want to show you what happens when I change something. So in order to write my construct library, I actually need some CDK dependencies. And CDK projects have this property called So this is the API for CDK projects. It's a pretty rich API. One of those capabilities is CDK dependencies. It's basically a list of CDK modules that my project depends on. And so basically, I'm going to need the S3 module in this case. Now let's run Projen and see what happens. I'm going to look at the diff here, and you see I can see my change here, but I can also see that my package JSON was changed, and you see that it automatically added these modules as peer dependencies, as in regular dependencies with the right versioning, and now it also executed yarn install for me, so I actually get these dependencies in my project, and so I'm ready to build my code. I actually have this code already built because I didn't want to waste time on that. So let me just copy and paste it for a second. This is just some sample code that Projen created for me. And this is the secure bucket. So it's basically a construct that extends S3 bucket and enforces the bucket is created with encryption. Pretty straightforward. You see the structure here is actually pretty modern in a way. And if you have experience setting up this structure where you have sources here and the sources are compiled into a lib directory and the test and jest is compiling TypeScript for you, it's not trivial. To tell you the truth, it's actually a pretty intricate configuration, and Projen just takes care of all of it. And so test, let's see the test. I also have the test here somewhere. Let's see. Again, this is not why this is interesting. And so I get the test here. But for example, I also get because this is set up properly, I also get automatic integration with Jest and VS Code. And so once I start the Jest runner in VS Code, I expect this to actually be tested automatically, but the machine is extremely slow, so it's going to take 2 hours. Okay, check. Let me show you a few other examples before we move on, just to whet your appetite. Let's say I want to publish this to Maven. So I have a Java property here, and this Java property here has a bunch of fields. And so Maven group ID would be whatever, and Maven artifact ID would be something like this, and Java package would be something like that. Let's see what that did. Bucket. I'm running git add again so that we can see the diff, and then run Projen again. Let me stop just because. And if I look at the diff, this actually changed 2 files. So it added a section in my package.json to publish Java, to basically build the Java binding and package it as a Java module. And then it also added a section in my workflow to release to Maven. And again, all of this is not rocket science, but who wants to understand what's going on here, right? I can just trust Projen to do whatever needs to be done in order to publish this library to Maven and PyPI and NuGet or whatever. And there's a bunch of other stuff like release management and changelog management, and we can add more features. And every feature that we add is automatically available to all the projects that are using this project type. So what's next? Projen is in alpha. There's a typo. Projen is in alpha. It's very early. It's a pre-release, so expect some breaking changes, hopefully with some notifications. I'm calling for contributors and also for maintainers. If anyone's interested in leading this with me and taking a more active role in the project, please reach out to me, and I'm happy to collaborate. I want to add more project types. I'm super interested in the web space because I feel like this can make a huge difference in this space. It's such a mess, and there's so many opinions and tools, and so having a nice API and a nice strong abstraction for that would be really nice. CDKTF would be really great to add, and we can add more features across the board, right? Like IDE integration, richer APIs, integration with different GitHub capabilities or other CI systems. So reach out on GitHub, on CDK Dev Slack, or directly on Twitter. Thank you so much for your time.
All right. Well, thank you very much, Elad. We appreciate it. As a CDK developer, I just saw like 4 problems you solved for me by having this. We're going to go ahead and continue on into the next talk. We'll see a lot of you around our lunch break, I hope. So our next one is going to be a gentleman named Ran. He's going to be talking about their particular journey from the software as a service industry and market as a whole, and their adoption of the CDK.
Hi, everybody. My name is Ron Eisenberg, and I'd like to share with you our SaaS journey with CDK here at CyberArk. So let's start. So like I said, I'm Ron Eisenberg. I'm currently cloud software architect here at CyberArk. Some of my hobbies include PC gaming, smart home automation, coding. I'm a little bit of a shopaholic, some would say, and I own an evil cat, as you can see by the picture. So a little bit about CyberArk and what we do. So CyberArk, as you might know, is the global leader in privileged access management. We have numerous solutions which are deployed on-premise and hybrid solutions or even in the cloud. But like other companies, currently we're moving into the cloud more and more. So this is where I come in. I actually had the privilege of joining one of the most interesting projects here at CyberArk this year, which is a pure serverless project, Python based, and it's strictly on AWS, not multi-cloud, but just AWS. So why did we choose CDK for our deployment solution? So at the beginning, we looked at CloudFormation, and we found it to be too low level and too complicated. So we started to look at other frameworks. We looked at Serverless and Terraform. So as you might know, Serverless and Terraform, they require you to write YAML files, JSON file, or use the HCL, which is a proprietary language. Now, to me as an engineer, I find it less readable, it's harder to debug, and it has a steeper learning curve to learn all the quirks, all the configurations that you need to learn in Terraform Serverless. One other issue is that it's not AWS backed, so new services or new services configurations and options might not be available as soon as possible. And another thing is that the main advantage of these frameworks is the multi-cloud support. But since we're going to be strictly AWS deployed, this advantage actually dissipated. So we then started to take a look at CDK. Now, CDK has a Python SDK, which means I can write the deployment configurations as code. And to me as an engineer, it's familiar and it's easier to me to read it. I can debug the deployment code in real time. It has a shorter learning curve. And the fact that it's AWS backed will mean that it will get all the support and all the new bells and whistles as the new services get published. So we started to work with CDK. Now, it wasn't, it took us some time to get the ball running, right? And to get the ball going. It wasn't as easy as we thought. We encountered some issues. We opened some GitHub issues. We found a missing feature in CDK. We wanted to create lambdas with custom dependencies. And it was a feature that was still under development. And we couldn't wait, so we had to develop something for ourselves. And we started working. And things started clicking, right? We had a meeting with CDK team, and they answered some of the questions. We implemented some of the missing features that we required. Some new features came out, and we started clicking and started to work. We also started to share more knowledge within the team, to share custom constructs that we created, and we finally got the first service deployed. So to me, the first time that I actually realized how great CDK was when I was working on the audit service POC. So what's the audit service POC? The audit service is basically a big data ingestion pipeline for audits, for logs. You get multiple logs from multiple customers, and you process them and you store them. And as you can see here, you have multiple services. You have S3 buckets, you have lambdas, you have API gateways, you have AWS IoT, you have Kubernetes, you have Kinesis data streams, and you have Kinesis data firehose, and even Elasticsearch. And you have to connect all these Lego pieces together, right? So we were 3 people, and it took us 2 days to connect all these dots, while we weren't very familiar with most of these services. So to me, in hindsight, that's just amazing. I mean, CDK has allowed us to actually create all of this in just 2 days. So what's the bottom line here for CDK? CDK has allowed us to focus more on implementing the business logic, right? We were able to focus more on the audit service POC logic after we connected all the dots. It made the deployment issue into a non-issue, basically. And the most important thing is that CDK has helped us to decrease the development time. So now that I think that I've convinced you that CDK is awesome, I'd like to give you some tips and insights to really improve your development time and reduce the development cycle even further. So the first thing that I want to focus on is the AWS Service UI. Sometimes the AWS constructs for a service that you want don't exist or don't offer all the options that you require. And it's a bit hard to understand how to connect all the CFN lower level objects together. For example, EventBridge. EventBridge, you don't have an EventBridge construct. You need to create an event bus, a rule destination, and connect it all together. So it's easier to go into the EventBridge service page in the AWS UI and try to create the EventBridge yourself. And then you will see how everything is connected, and it will be easier for you to connect the CFN objects by yourself. So this is very helpful. I've used this numerous times. Another thing is, don't be scared to use CFN lower level, right? You don't always have to use the higher abstraction level constructs. Sometimes you just need the lower level CFN classes because they offer more options. For an example, S3 buckets with more advanced object retention options, you have to use the lower level CFN class, which is just okay, just a bit harder to configure, but sometimes you just have to get it done. Another thing that is highly important is to share constructs between teams. Share knowledge. The more and more you share knowledge and constructs between teams, the more you reduce your code duplication and decrease the dev time. Another issue is since our team grew during our time, it just continued to grow, and we had new engineers. We created a small CDK training program to get people going quickly. We actually had a webinar on CDK and a repo that they can play with, and this has been really helpful for us to get people into CDK more quickly. Also, you can use the CDK patterns library, which is relatively new. It's basically a library of constructs that are design patterns that we usually use, and AWS just created those for you, and you can reuse them and use them in your code and reduce them. You don't have to write them yourselves. And when everything seems bad and you just need some help, you can always use the Slack channel, the AWS Developer Slack channel, and go to the CDK channel and ask around for help. So what's next for us? What's next for us in our CDK journey? So we'll continue to share knowledge and experience. We have a blog series in this URL. We're talking about CDK and AWS in general. And we're doing webinars now on a regular basis. We have a CDK intro, which we're using at the CDK training program, which you can find in this URL. And we have the AWS IoT introduction webinar in this URL. And we'll probably continue to donate code to AWS open source repository. So if you have any more questions, or you want to follow my blog at a Medium or my Twitter, here are the links. And thank you very much for listening. Bye.
Yeah, thanks, Ron, for this incredible journey report. So, some seconds about me. So, this is my first time on camera for today. So, my name is Thorsten. I'm a freelance consultant, and I'm your host, one of your hosts today. And yeah, so with no further ado, I think we'll directly transition to our next great talk that I'm really looking forward to, because AppSync is something I'm writing right now on a project. So we'll have Nader talk about building real-time backends on AppSync with CDK. And I think this will be a great talk.
That's right. I'm excited about this. If you watch, you have to keep up. Nader is the fastest coder on the face of the planet. So I've watched him in meetings create full applications while I was trying to stay awake. So without further ado, we're excited to see you, Nader, and here we go.
Hello, everyone. Welcome to my talk. Today, I'm going to be talking about how to build real-time backends using GraphQL, AWS AppSync, and CDK. I'm really excited to be here at CDK Day, my first CDK talk, so I'm pretty excited about that. My name is Nader Dabit. I work as a senior developer advocate on the web and mobile team here at AWS. Been here for a little over 2.5 years. So let's go ahead and dive right in because we have a lot to cover. First, I'm going to be doing an introduction to GraphQL. We're going to then look at AWS AppSync and how GraphQL fits into that. We're going to then look at how the CDK classes and constructs allow us to use AWS services to build an AppSync API. And then we're going to do a live coding demo, building an API from scratch and deploying it and testing it out. So let's dive into GraphQL. What is GraphQL? Well, if you look on the internet, you might see this definition, a query language for your API. This doesn't really tell you a lot about what GraphQL is, so let's dive a little deeper. At the end of the day, a GraphQL API allows you to do this. You describe your data using a GraphQL schema, and your data is not only described here in your schema, but also the operations against your data. So here you might define a type of project, but you also might define methods to create, read, update, delete, and subscribe to different projects being created, updated, or deleted. You might also have a definition here for a real-time operation for when a new project is created, you want to subscribe to that update. So you have your schema describing all of your data. And then once your API is live, you can then ask your API for the data that you would like. And one of the powerful things that GraphQL brings to the table is this idea of only getting the data that you've asked for. So if you've ever worked with a REST API and you have an endpoint for something like people, and then you get each person, they have maybe 10 or 12 different pieces of metadata that you have there, but maybe you only want the name. With GraphQL, you can only ask for that data. So you can ask for only the data that you want without having to modify your API. Once it's there, it works, and you get only the data that you'd like to be returned. So let's take a look at how a GraphQL API is built. A GraphQL API consists of 3 main parts, which we'll dive into a little deeper. You have a GraphQL schema, you have your resolvers, and then you have your data sources. The schema is what we looked at just a moment ago. It's essentially all of the data and all of the operations that are available for your API. So for a simple to-do app, we might have a type of to-do, a few different fields on that to-do. If it has an exclamation point, it's a required field. If it does not, it's nullable or it's optional. We then have different operations like queries and mutations, which map to REST calls of something like a get or a put or a post. So after we've defined our types, our operations, we're now ready to move on to the next step. We then need to have data sources. So when we're operating with these queries and mutations, where is this data coming from? That is where we define our data sources, and then we have our operations that map to these data sources and bring data back to the API in the response. So how does this mapping happen? The mapping happens using GraphQL resolvers. And GraphQL resolvers are really an implementation detail depending on the person building the API or the service. And essentially what they are functions or some type of code that maps the operation to the data source. So this might be Python, it might be TypeScript, it might be whatever your language is that you're using for your API, or if you're using a managed service, whatever their flavor is. Data sources come in a bunch of different ways. So you could think of a data source not only as a database, but also as some type of either a mapping to some other service somewhere. So maybe some microservice, or even to a serverless function, which we're going to be doing here in our example. One of the really interesting things about GraphQL is the data fetching. So let's dive into that a little bit more and look at the differences between GraphQL and REST. Well, in GraphQL, like I mentioned, we have this idea of queries, mutations, and subscriptions, and these actually map really well to HTTP requests. So when you think of a query, you're typically going to be reading data. When you think of a mutation, you're typically going to be creating, updating, or deleting data. And then if you need any type of real-time updates, those are typically done in the subscriptions. And then after we kind of understand this at a base level, we can now kind of map these operations to HTTP verbs that we're probably used to working with. So when we think of a GET request, all of this is going to be mapped to a GraphQL query. Everything else is going to be mapped to a GraphQL mutation. So posts, puts, deletes, patches, any type of update, you could think of that being done in a GraphQL mutation. Any type of reading is going to be done in a query. And then once you know that, you're kind of good to go as far as theoretical ideas around data fetching in GraphQL. So let's take a look at how these GraphQL operations actually work. Like I mentioned with at the beginning, one of the really great things about GraphQL is that you do have the ability to only fetch the data that you would like. So let's take, for example, we have this base query of get to do, and the to do type has 4 fields. We have an ID, a name, a completed, and a created at field. We can map this operation and we can say, okay, we want to get all of this data in this request. So we're going to say get to do. We want to return the ID, name, completed, and created at values. We'll get all of that back. But what if we only wanted a couple of these fields? We could do that as well. All we need to do would be to change our query, and whatever we would like to be returned, in this example, just the name and the completed values, that's all that's going to come back, therefore reducing the payload size for this operation. So next, let's take a look at GraphQL subscriptions. This is kind of the real-time aspect of GraphQL. GraphQL subscriptions enable real-time communication between the client and the API. Subscriptions are event-based, so if you've ever worked with some type of mutation in your API, you can then attach a GraphQL subscription to that. So let's say you have a typical CRUD app, create, read, update, delete, and let's say we have a to-do app. You might say on create, on update, on delete. I want to subscribe to all of those changes, and then you can have a subscription open between your API and your client. Any data that is going to be part of those events of the create, update, or delete will then be sent down to the client. This is done in a two-way communication. So when you open a subscription, you have a way to communicate to the server and the server back to the client. And the implementation is kind of not really specified. So there's a GraphQL spec for the subscription, but the implementation is kind of up to you. So if you're building out your own API, you might use something like WebSockets, or you might use something like server-sent events. But most of the time, you're seeing people using WebSockets for GraphQL subscription. So they're implementation agnostic, but typically they're done using WebSockets. And subscriptions work really just like mutations and queries. You say you define your subscription, and then you can then use that subscription or subscribe to these changes on your client, and then you're getting the data that you would like to get back. But just like in GraphQL mutations and queries, you can also only ask for a subset of the fields. So in this example, we have an onCreate to-do subscription that's available. We can get the ID, name, completed, and created at values back. But maybe we only need the ID, the name, and the completed values. We can create that subscription and have that work just fine. Here, we're going to say, okay, we only want the ID, the name, and the completed values. We're only getting that data back in the subscription. So now that we kind of have gone over GraphQL briefly, let's now look at AWS AppSync. Well, AppSync is essentially just a managed GraphQL service. So you have all this stuff built in for you. And what a lot of people are using AppSync for as kind of like an API gateway or a consistent API layer for any AWS service or any AWS data source. With AppSync, we have conflict detection and conflict resolution built in if you need that. And this is done both on the client and on the server using our client-side SDKs and libraries. We have enterprise security features built in. So if you need some type of auth or multi-auth, we have that built in using Cognito. You can bring your own auth provider using OIDC. IAM, API keys for public access, or a combination of or two or more of those. And we make it really easy to add real-time functionality to your app, as you're about to see in just a moment. So any mutation has subscriptions built into the service. So all you need to do is add one line of code into your GraphQL schema, one additional line of code, and you're ready to go with any real-time updates for any of your mutations. And then we also have that we maintain for our team client SDKs for web, iOS, Android, React Native, and Flutter now. So AppSync with CDK. This is what we're here to talk about. Let's now talk about using all of these ideas that we just talked about with CDK, how this is going to actually happen, and kind of build this out in just a moment in a live demo. So to get started, we're going to install the CDK packages that we need. So with AppSync, you're not only going to install the AppSync CDK packages, but you're going to also need packages for all of the other, data sources and services that you might be needing as well. So for a typical GraphQL API, you might need a Lambda function, you might need DynamoDB. So you would install all of these things like you would in a normal CDK app. You then create and configure an API. So once we've installed, our CDK for AppSync and other data sources, we're going to then kind of create an API reference, and then we're going to start modifying that API by adding data sources, adding resolvers, and things like that. So we're going to add data sources. We're going to then add resolvers to these data sources, and then we're going to deploy, and we're going to kind of have our CDK app. So I think that is an intro, but I think really the interesting part is actually doing this in code and seeing the code itself, and then deploying it and actually testing it out. This is the fun part, and I think this is where you're going to learn a little bit more about how all this works. So let's go ahead and test this out. What I'm going to do is I'm going to go into a folder where I've created a CDK project. And here, basically, what I have done is just initialized a new TypeScript app with CDK. And I have installed a couple of node modules. The node modules I've installed are CDK AppSync, DynamoDB, and Lambda. And what we're going to do is kind of build from scratch our entire app, and we're going to kind of deploy that and hopefully get that done in just a couple of minutes. So like I mentioned, the first thing we need to do is create the API. But before we do that, we need our imports. So we're going to go here to the top of our file. Whoops. And we're going to go ahead and import the things that we need. So we're importing AppSync, we're importing DynamoDB, and we're importing Lambda. Next, we're going to go ahead and create the API. So here we have our API declaration. We're calling this API. And then we're going to say we're going to need a new AppSync GraphQL API. We're going to then give the API a name. And this is going to be the name that is in your dashboard. So in the service itself, this is kind of what you're giving the name to this API. I'm trying to zoom in to where this looks good. I think this is a good zoom level. So the name of this API is going to be CDK Notes AppSync API. We then need to define our GraphQL schema. And this is essentially going to be kind of the location for your GraphQL schema. So I've defined this as GraphQL/schema.graphql. And here in this GraphQL folder, we're going to write our schema in just a second. And then we have our authorization configuration. Now, I mentioned that we have authorization and all of that built into the service. And you can do multiple authorization types. And to do kind of your authorization configuration, you need to have a default authorization, and then you add any additional authorization modes. So you need one default. And for this example, I'm using a default of API key. And then also I'm kind of showing here, if you'd like to have additional authorization modes, there is a field that you can add or a key for additional authorization modes. And then I'm just enabling X-ray so we can get a little bit more detail about the logging. So now that we've done this, we want to go ahead and look at our GraphQL schema. So I'm going to go here, and our schema is empty, but we're going to need a schema for a Notes app. So I'm going to go ahead and create a schema here. So we have a type of note, and the note has an ID, a name, and a completed Boolean. We then want to define operations against this note. So we have a query, we have a mutation, and we have a subscription. The query that we have is a list notes query, and this returns an array of notes. We also have a create note mutation that takes a note as an argument and returns a note. And for GraphQL input types like this, we actually have to define a separate type. So we have a base type and then we have an input type. Input types are essentially the arguments that you're going to be passing into your operation. So that's kind of why we have this note input here. And then we want to make a subscription for whenever someone creates a new note. So what I've done here is I have on create note. And this is kind of the description definition itself. But to enable subscription on the service, to kind of have all of this configured and wired together on the service side, all we need to do is say at AWS_subscribe and pass in the array of mutations we would like this subscription to fire on. So here on create node, we want to make this subscription fire when a new node is created. Therefore, the subscription operation that we're passing in here for the mutations is create node. So whenever someone creates a new node, this subscription is going to fire, and therefore we have our real-time functionality going there. So our schema is done, and we can close this and continue on. So the next thing we want to do is do some logging. So we might want to, for our client application, have the GraphQL API URL. We might want to have the GraphQL API key and maybe even the region. So that's kind of some pretty basic logging stuff we're just going to log out there. The next thing we might want to do is go ahead and add our data source. So for this, we're going to have a Lambda function as the data source, meaning we're going to map all of the GraphQL operations into a Lambda function. And in the event, we're going to then have all of the metadata about the operation. So we're going to have arguments. We're going to have things like the query or the mutation. We're going to have the field names. All that stuff is going to be there in the Lambda, essentially turning this into something like a GraphQL version of API gateway mapping to Lambda, if you've ever worked in that scenario, opening up a lot of opportunity for you to do stuff, and also letting you write in your own favorite programming language. In this example, we're going to be writing in JavaScript or TypeScript. So to do that, you've probably set up a Lambda before if you're here at this event using CDK. If not, we're just kind of creating a new Lambda function with a couple of pieces of configuration. We're going to go ahead and set the folder as Lambda FNS. So I have that folder created here with a few empty functions. We're defining the handler, and we're defining a memory size. And then we're attaching this function as a data source by this line right here, which is really interesting because this is kind of specific to AppSync. We're saying, we define the API way up here. Go up a little bit. We define the API right here. We're saying const API. And now we're actually using that right here. We're saying API.add Lambda data source, passing in the data source name or reference and then the actual data source. So now that we've created that data source, what we can do now is create resolvers on the data source. So what we want to do is have two resolvers. One resolver for the query and one resolver for the mutation. We don't need resolver for the subscription. Subscription is going to be wired up automatically for us. So here we're saying we want to say Lambda data source, create resolver. The type name is query and the field name is list notes. So if we go down to, if we go back to our GraphQL schema, we'll see that we have a field of query. We have a type name of query and a field of list notes. We have a type name of mutation and a field of create note. That's kind of what's going on here. We're just kind of referencing those fields and those type names. Finally, we want to do something with this operation. So what are we going to do? In this example, we're going to map this into a DynamoDB operation. So what we want to do is have a new DynamoDB table. So that's what we're doing here. And this is kind of the 4 new lines we just added. We're going to create a table called notes table, creating a new DynamoDB table. We're going to then grant access from the Lambda function to the table using notes table.grant full access notes Lambda. And this way, the Lambda can operate against the DynamoDB table. And then we're going to create an environment variable because we're going to need a way to reference this table name in the Lambda function code dynamically without hard coding anything there. So what we've done now is kind of built out this thing from top to bottom. We created the API. We then created a Lambda function as a data source. We then created resolvers to map to that data source. And then we created a new table that is going to be having access from that data source, which is the Lambda function. And this is it. This is all we need to do. And we did this in like, about 70 lines of code, give or take. Actually 60 or so if we remove the comments and other stuff. And then we're really done. We can go ahead and save this and jump out. So what I want to do now is we need to actually write the code for these Lambda functions. So we'll jump through this real quick. We have a note type for since we're using TypeScript. The note is going to kind of be mapping directly to our GraphQL schema, which is pretty nice. So we have an ID, a name, and a completed Boolean, and then we're done there. I think the most interesting thing is going to be here. When we're going to look at this main entry point for our Lambda function. So the entry point for our, for the function is going to be this main.ts. And here in the event, we're having this AppSync event that I've created a type for. So you can kind of get a decent idea of what's coming into this event. We have two main properties we're going to be working with off of the event. One is the info, and this has information about the operation itself. So things like the type name and the field name, all of that's going to be here on the info object. We also have arguments. So any arguments that are passed into the operation, be it a query or a mutation, will be available in this arguments object. So in this example, we're saying, okay, we have the note ID or the note. All these could be part of this of the arguments. And then in the actual event, we're going to be using actually three different fields off of the operation. We're going to be saying we want to use the info.field name, and the field name is going to basically be create note or list notes. We also have the note itself, and the note is of type note. So we might be having a create note, and then also if we ever needed to get note by ID or delete note, we could have the note ID available as well, and that could be passed in as a mutation, even though we're not really using it. So I guess the two fields or the two properties that we're going to be working with are the event.info.field name. That is going to be either create note or list notes. And then we have the event.arguments, and this is going to be like the arguments that are passed in. And right now we only have a note that we're going to be working with. If it's the list notes query, we don't need any arguments. We're just going to scan the DynamoDB table and kind of return all the results there. So that's the main entry point. Let's go ahead and save that, and then just go ahead and create these two functions. One is list notes, and this is just going to perform a DynamoDB scan. We are referencing the process env dots variable, so notes table. This was what we created in our CDK app. And then for create note, this is a pretty basic operation, DynamoDB put. We're just going to take the note, and we're going to say the note is the item, and we're going to call it .client.put. And basically, we're interacting with DynamoDB from our Lambda function. So we're ready to test this out. So what I want to do now is go to here, and we're going to say npm run build. Go ahead and build this out. And then once the build is done, CDK deploy. And what we're going to see is that we're going to go ahead and do this one operation. And after this is done deploying, we should have our working API. So we will go ahead and give that a second to deploy. And once it's deployed, we'll see that we have our API key logged out. We'll have our GraphQL API URL endpoint, our region logged out. We should be ready to test this thing out. So what we'll do is we'll go to the AppSync console. And I'll zoom in a little bit, or a lot bit. Oh, that's too much. And we're going to look for the Notes app. And there we go. So our API has been deployed. Now we're going to test it out. So let's run a query that we probably know is not going to be there because there's no data there yet. But let's go ahead and try it out anyway. See if we can get like an empty array back. All right. So operations seem to be working. So let's go ahead and create a new note. We got to pass in a notes. All right, so there's our note. Looks like that came back successfully, and we now see that our API is working. So let's create one more notes. And what we want to do now is test out the real-time functionality. So we want to test out that GraphQL subscription. So what I'll do is I'll go ahead and open up a new tab over here. And I will open another version of the console over here. And what I'd like to do is create a subscription. So I'm going to say subscription on create notes. And when a new note is created, I want to get back maybe just the name and the completed value. So let's go ahead and subscribe to that here, and then we'll do one more. We'll do like a real-time notes. And there we go. The real-time data comes through in our subscription. And we are now subscribed to changes. And, whoops. Let's do one, change this a little bit. And we see that those changes are coming through here. So that was it. That was pretty simple to create, an API from scratch. We did that in just a couple of minutes. So, and with that, I will go ahead and finish this off. So thank you so much for checking this out. My name is, again, Nader Dabit. I'm Dabit3 on Twitter. If you look on my GitHub, you'll actually see this project, there for you to deploy. It's called AppSync CDK Backend. So if you're interested in that, go to github.com/Dabit3. And you'll see that the CDK AppSync backend project is somewhere at the very top of my GitHub repos. So again, thank you so much for watching. I hope you learned a little bit, and I'm looking forward to seeing the rest of the talks for CDK Day.
Yeah, thanks, Nader, for this perfect talk. And I was so happy to see this because, a spoiler, I wrote the initial AppSync code in CDK, so I'm really happy that somebody's using it. And and you can see a blog post he wrote on the AWS blog. It's about 2 days old, I think, so you can read all these things again. Over to Marek.
Yeah, thank you so much. Thanks also, Nader, for a great talk. So the next speaker is actually going to be talking a bit more from a security perspective. So the next speaker is going to be Julia, talking a bit about how you can use actually CDK in a FedRAMP setting. So in a more sensitive, environment where obviously security and privacy are very important. So I see Julia's already here. Hey, good morning there. Nice to have you here.
Thank you.
We're going to hand it over to you for your talk. So good luck, have fun, and see you after the talk.
Great. Thanks, Thorsten and Marek. Thanks for everybody being here for my presentation. Hope you're having a great time at CDK 2020. Lots of great talks going on. This presentation is about how AWS CDK was used to create a FedRAMP compliant infrastructure. I'm going to get started by introducing myself. My name is Julia Jacobs. Currently, I am a senior cloud automation engineer for a company called Axiom. Axiom specializes in providing data to marketing companies. I'm going to talk a little bit about my cloud background. I've done a lot of work for infrastructure as a service companies like Rackspace and BMC. I was a Heroku platform engineer at Salesforce. I was awarded the Azure BizSpark startup program and got the AWS Associate Solutions Architect certification, and really, really happy to be part of the AWS Community Builder program. This presentation is going to be a little bit more in a story format. I'm going to discuss a use case from a company that I worked at. And so let's go back to the beginning. This company is a healthcare broker. The product that they provide is targeted towards individuals who are not qualified to get group healthcare plans. So they offer a choice of healthcare providers with minimal anonymous customer input on their website. The idea is there's a easy, friendly, non-invasive experience on their website for healthcare shopping. The application architecture and infrastructure is like a step above MVP. It's very simple. It's what they call MERN, which is similar to mean stack, but you have React, Redux, MongoDB. The cloud service provider they were using was Heroku, and they were using the Firebase OAuth service. So super simple, not even set to scale. They were on a single dyno, no kind of logging or statistics to find out, whether they needed to scale or not. They were at a place where they wanted to improve the customer experience. When they, during the process of having a customer find providers from the government healthcare exchange, all they offered on their website was a redirect to the healthcare.gov website, which really wasn't ideal for the user experience. So what they wanted was tighter data integration with healthcare.gov, so they could show the information from the healthcare providers within their search results, as opposed to just a redirect. The problem is getting access to that data from healthcare.gov requires FedRAMP compliance. On this slide, I'm going to put a couple of links in this presentation to resources of interest. And I just thought anybody who's interested in finding out more about government APIs or data sources for any type of healthcare projects, you can go to cms.gov and take a look at their APIs and data sets and any information on using them. I was just reading TechCrunch yesterday, and there was news on startups that were in this space, and how hot things were with COVID and everything. So anyway, so what is FedRAMP? Unlike something like HIPAA, which is a security standard that is very generalized across the board, FedRAMP is specific to the cloud service space. Just straight off the FedRAMP website, here's a definition. FedRAMP simplifies security for the digital age by providing a standardized approach to security for the cloud. FedRAMP facilitates the shift from insecure, tethered, tedious IT to secure, mobile, nimble, and quick IT. So in the search of FedRAMP compliant cloud service providers, who are you going to use? Obviously AWS, obviously, right? Why AWS? AWS has a number of FedRAMP compliant services. And you could see this, they list them in scope. You click on the FedRAMP tab here, and you can see all the services. So if you're looking to create a FedRAMP compliant application, you can consider what product you want to use, and then you can see whether it's compliant or not. Just as an aside, if you're, obviously you want to use, like S3, like an S3 bucket, even though it says it's compliant, if you set up an unencrypted S3 bucket, obviously you're not following the controls of compliance. So, that's something to consider. Oops. The other product that AWS provides for FedRAMP compliance is a FedRAMP security package called AWS Artifact. And this is available. You actually have to have an account and log in to take a look at this. When I came onto the company, I kind of had this vision when it came to performing this migration. My background is not just on the architecture side. I've kind of worked in lots of different areas in the development life cycle, or I don't know what you want to call it. I've worked on the creative side, development, project management, API, I don't know, front end, back end. So, and I've also been an organizer for different meetups and pair programming meetups, and done training. So for me, when I come into a company, and one of the reasons I came to this startup was I wanted to be a part of a culture or influence a culture where folks could have a career path and not be pigeonholed, and just own every aspect of that software process. So I wanted the migration process to be a part of that, to be kind of keeping that culture in mind. So when we discussed migration, I made that part of my suggestion on how we were going to do that. So they had hired an architect consultant before I came, and his suggestion to perform the deployment was a kind of a lift and shift. And he said to hire a DevOps person and deploy a NIST quick start template. I don't know, for those of you that aren't familiar with AWS quick start templates, they're CloudFormation templates that you can deploy that sort of create out-of-the-box infrastructure. So this NIST template actually creates an infrastructure that's FedRAMP compliant. It's good for a lift and shift type architecture. You see, you've got like the standard 3-tier. You have development and production. You have this management VPC, which you can use for auditing and managing roles and policies and accounts. So that this was his solution. What I proposed was to use some kind of serverless framework or solution to train and empower the developers to own the infrastructure with guidance from a mentor. And luckily, I was able to get buy-in. So that's kind of how I was able to introduce AWS CDK. So that's kind of part, again, this is sort of like part of the story. So the next part of the puzzle was talking to the audit consultants. This is sort of what it was like talking to the audit consultants. The FedRAMP culture was a little stuck in 2012 when it came to cloud architecture. I mean, they're not really now. There's been a lot of work in that area, but at the time, it was a little bit challenging to work with them to get information on, can I do this? Can I do that? What do you think about this architecture? And they really couldn't think beyond like standard, EC2, sorry, like kind of that EC2, like what I showed you in that NIST template. So that was a bit of a challenge, but I pushed ahead and evaluated different types of platforms and serverless solutions, and found AWS CDK. Yay! The best thing out there, obviously. So I'm sure everybody's talked about why AWS CDK is awesome. I've got a bunch of bullet points why it's awesome. But we had those React Redux developers. They looked at the code, they saw the design pattern. Hey, we know that. Modular. I passed over serverless.com because it's a little too much infrastructure as YAML. The CTO loved it. I showed him the video from reInvent, I think it was 2018, and it was love. And of course, everybody knows the AWS CDK team and community are awesome. So that's actually a big deal when it comes to choosing a solution. I'm not going to really get into some of the other things I looked into, but definitely interaction was not as positive. So after I got the buy-in, as part of the fun stuff began. I created some cool looking architecture diagrams, dug into those AWS CDK docs, the repo, did the tutorial, and I created my first shiny new CDK app. A 3-tiered infrastructure. And I don't know, for those of you that start off with the infrastructure, a 3-tiered infrastructure is basically this. CDK, it does a lot of heavy lifting with some of the methods, but I mean, I guess the point is I didn't know a whole lot, but I got a whole lot in return. The big pain point when it came to working with CDK and the engineering folks and the CTO was this paradigm shift from a PaaS product integration like Firebase, MLab, and Heroku to AWS to that shared responsibility model was, I had a number of issues. The CTO we didn't have multiple environments. There was production, and everything went into production, and there was a number of accounts in production. So, we had a number of S3 buckets, no encryption. It was difficult to, there was a lot of training involved. It wasn't just training AWS CDK, it was security training. It was sort of like DevOps training. It was just like basic 5-pillar AWS training. There was just a lot of training that I needed to do. I had to create multi-account environments. I had to explain, why we deploy. I mean, why we bother with automation. Why we can't do everything through the console. And the way that I was able to sort of get around that without sounding like just a nag that, made everybody's lives difficult, was, hey, you guys want to be FedRAMP compliant? Well, you can't be FedRAMP compliant unless you do these things. And, we had this big FedRAMP security controls baseline. These are like the laws. And, we had things like separation of duties. So, every account had to be, sort of equal a roles. What are you doing in the company? Well, we have one admin, so we need an admin account. Only one person can deploy things. We have least privilege. Well, that's a control. We have to do that. Otherwise, we won't be FedRAMP compliant, and you can't do the thing that you hired me to do. So, and the big thing was everything is audited. So I would say, okay, well, if you don't want to deploy this in production, or, then you have to create a run book, which is kind of a pain in the butt. So, it's like, all right, okay, we'll deploy it. So, it was a little pulling teeth with all of this. And that was kind of a big deal. But we got a lot done. The migration plan consisted of taking Firebase OAuth and migrating it to Amazon Cognito and creating a CDK app for Amazon Cognito. The data migration was a little tricky because they wanted to, first they wanted to do a remodel on the data, which took forever. And then they wanted to, work with Heroku Postgres SQL. And then we had to kind of create a, use VPC peering from Heroku to like some DynamoDB, Lambda apps. And then I wound up creating a CDK RDS app, but we never really used the RDS instance because this never really got worked out. For the API services, I really wished we could have used AppSync for this. but I just couldn't make the training happen. I couldn't really get the buy-in for that at the time. So, this became, let's throw all this into a Docker container, and then let's do the, ECR, ECS, Fargate process sort of thing. So that was a CDK app, and then the static front end wound up in CloudFront, and that was a CDK app. So we were able to get everything into CDK apps. So that worked out. And all these are links to, you've got the module, everything here. I notice I'm sort of running out time a little bit, so let me just go through this super quick. We had some sticky points. These are some sticky points, and this has to do with the time that I was there. A lot of this has been no longer applies. Amazon AWS was not GA when it came to CloudFormation support of code pipelines, secrets manager, parameter store, ECS, ECR, incognito, which made things difficult. Until CDK supported the injection of AWS SDK API calls with AWS custom resources, I was not able to manage secrets in my CDK app. With the support of the AWS CDK team and community interaction, I was able to create a multi-service, multi-account pipeline. One of the great things you're going to hear today is information about creating these pipelines, which is an awesome thing. I created some CDK modules. To go through this really quick. Another big deal in this company was open enrollment. This is when people can enroll in a health insurance plan. This was 90% of the revenue of the company. Rapid call center expansion, high stress, constant website triage, tight website feature demands. So when this happened in the company, sort of everything sort of fell apart, and the focus shifted to marketing tech and analytics products, and the decision was made that compliance was not worth the investment. And I was hearing things like it's cheaper to write code than work with cloud products like GovCloud, Macy, data migration, etc. We just couldn't get out of startup firefighting mode to train anybody. We really just didn't have enough talent to support the work involved, and we couldn't compete with easier to use services like Sentry versus CloudWatch, Circle CI, GitHub Actions versus Code Build and Code Pipeline. We wrote all these CDK apps, wrote a pipeline, nobody was using it because we just couldn't get anybody off of Heroku, just because, we got to write features, it's just like couldn't get out of that firefighting mode. Let me go back just to say, they just weren't making enough. The reason that they wanted to be FedRAMP compliant, it wasn't making them enough revenue. 90% of their revenue was from call centers. So they didn't want to make the investment. The moral of the story is compliance is really expensive. You have to, it has to be worth it. So it wasn't, and that was the problem. So where am I now? I'm a senior cloud automation engineer for public cloud department in a multi-billion-dollar company. Axiom is owned by IPG Group. That's a huge company. I am in charge of creating custom security validation, evidence, serverless application, and infrastructure development in AWS. I get to work with, enterprise landing zone infrastructure, consult on AWS products, work with AWS product teams. I get to play with the real expensive AWS products. I don't have to worry about any of the, costs. So I guess we really can't do Q&A because it's so this is actually this is the presentation. Let me put this in. I'll put this in Slack, but that's it. And thanks everybody for being there, and I hope you enjoy the rest of the day. Thanks a lot.
All right, Julia, thank you so much for coming by today and giving us a talk about your experience with getting this, getting your organization moved over to the CDK. It sounds like you found a lot of problems along the way, but in the end, it sounds like you won the day with them. So congratulations. Thank you again for coming by. So we are now officially going to kind of take a little bit of a lunch break. If you need to step off for a few minutes, you're more than welcome to. We're going to bring on some of the hosts and some of the speakers and have a little bit of a roundtable discussion and talk for about the next half hour into our next talk. So first, I want to introduce you to Matt Coulter. Matt is actually the guy who originally came up with the idea of the CDK Day, and he has really put this thing together and led the charge on it. So Matt, why don't you go ahead and introduce yourself?
Hey, so for anyone who doesn't know me, as introduced, I'm Matt Coulter. I'm an architect for Liberty IT, which is in Belfast and Dublin, but also Liberty Mutual globally. So basically, to explain why I wanted to do CDK Day, let me briefly explain what my role is. So if you Google at any point serverless Liberty or Liberty Mutual serverless, you'll find that Liberty loves serverless. We believe in rapidly delivering business value through sustainable, well-architected pipelines, and we want to live that serverless first lifestyle. So my role is pretty much for hundreds, thousands of developers worldwide. How can we make that happen? I'm not in a dev team anymore. My role is to create an environment where our developers are enabled and inspired to do that. So that's why I've spent this year creating CDK patterns, which followed a lot of the principles that Werner talked about yesterday in his keynote. How do we create abstractions that can deploy serverless, well-architected patterns and accelerate developers in one line of code? So I'd been building those patterns and I'd seen that the adoption had been phenomenal, but it was a couple of months ago and it was pretty much mid-lockdown, and I was thinking, who is everybody that's using CDK? We don't meet up very often at all. In fact, so there's the CDK Power Hour in Germany, which has an international version. But outside of that, the only other place I know that we meet was last year at reInvent. There was an open bar session. Mm-hmm. So I sent a message to a group of y'all, and 2 weeks later, we announced CDK Day to the world. So it was pretty rapid.
That's awesome. Yeah. And, this has been about 6 or 8 weeks in the planning, and to get up to, the 3,000 people we had signed up with is just absolutely amazing. So thank you for all the effort you put in together on this and really organizing all of this and promoting it and everything. I think it's come together really fantastic. So we're also going to bring in Merrick. Some of you have already seen Merrick. He's been helping us with the transitions and the co-hosting on this. Merrick, can you go ahead and introduce yourself again real quick?
Sure, yeah, thank you so much. So my name is Marek Kuczynski. I'm a solution architect at AWS. Sorry about that. And I work actually mainly on serverless architecture. So basically helping customers with, implementing serverless, a bit of education. And over the years, actually, one of the reasons why I'm also involved here, I've been a huge, initially actually a Terraform fan. Then I moved on to SAM. But kind of the CDK thing was something that really struck me and a lot of my customers as well. So yeah, super excited to be here at this day. I think also, it's coming together really well so far. And happy to see this actually a reality. So
excellent. Thank you for joining us today and helping with all this. We've also got Thorsten. Thorsten's been also helping us with some transitions and hosting. Thorsten, welcome again.
Yeah, hi.
We've also got a special guest. This is Sebastian. Sebastian, can you go ahead and introduce yourself and tell you how you're involved with the CDK community?
Yeah, thank you. So I'm Sebastian Kaufmann, and well, I'm primarily involved in the Terraform CDK or CDK for Terraform, as Mishra mentioned earlier in the session. And then, like, Matthew and I teamed up for the CDK dev thing, like the Slack channel, which is everyone using at the moment. And yeah, I started to run a newsletter, and yeah, so at the moment, pretty deeply involved in the entire CDK ecosystem. And happy to be here. Thank you for having me.
Excellent, thank you. We're going to go ahead and bring back also Elad. He, was involved as principal engineer on the CDK team. He gave that talk early on Projen, which has been, garnering a lot of attention over on the Slack channel. We see a lot of people talking about it, which is really cool. We're going to see exactly how many people we can get in this. We've got the 6 panels so far. Let's see if we can toss in a few more people in there. We got Mishra back. Mishra talked a little bit earlier about the Terraform CDK. Welcome back, Mishra. Thank you again. We've also got a very special guest coming up next. You may have seen him in a different guise before, but now we'd like to formally introduce you to the official/unofficial CDK mascot.
This happened. Hello, everybody. I am Pancakes. They made me put this on, but that's okay. I can't type in these. First time ever I've had more than one finger, so that's interesting. So yes, if you've seen me before, you've seen me in a squirrel outfit, and now today I'm in the Pancakes outfit. So try to keep a straight face. Just try to keep this professional. Let's move on here. So I'm thrilled to be here, very honestly. I will tell you, so far, I have learned a ton about CDK, and I've been very interested. Elad, I want to take a minute and ask you about, first of all, am I saying your name right? Elad? Okay.
Yeah.
All right.
Elad is the...
Right. So what that nod that Elad gave me was that's the closest you're ever going to come to it.
Yeah, exactly.
So Matt and I decided, first of all, that I look hot in this, so I'm now calling myself a hotter. So just throwing that out there. So Elad, there was a lot of great response with Projen. What's next? I mean, you kind of talked about it there, but seeing the response, what's next with Projen?
For Projen?
Yeah, Projen. So I said that wrong too. Yeah. Thanks for correcting me live, though. I appreciate that. I'm an otter, dude. Come on.
As I said, I think it's an open source project, and so what's next is just evolution, right? Like organic evolution, getting more people to use it, provide feedback, submit issues and pull requests, contribute, making it getting it to a place where we feel it's stable and powerful. We're actually using Projen in CDKs. The CDKs repository is using Projen itself. And we're planning to use Projen for the CDKs init command. And I hope that when it stabilizes sufficiently for the AWS CDK, which is in a different state, then maybe we'll use Projen for CDK init, which currently is based on some templating and stuff like that. But the idea is just get people to use it, I guess.
I'll quickly kind of insert myself here. Actually, Elad, Sebastian's using Projen for our pre-populated generated providers repository and organization. So all our new like kind of pre-built providers are being shipped using that.
Yeah. And also, Projen officially makes one of my first CDK blogs completely redundant about how to set up that, which, as a developer who would prefer to remove code than add it, I'm actually really happy about that. I like the fact that people don't have to follow some 30-step process to get CDK constructs building now. Now they just type a couple of buttons, and like a lot of what the CDK does, it makes it really simple to do complex things. So awesome job. Can't wait to start using that on all of our projects.
Yeah, let me know what you think. I'm very interested.
Will do. So we did have one question that came up in the chat. I wanted to go ahead and mention it here. And then the rest of this discussion is mostly just going to sort of be a little free form for the next 20 minutes or so until we get into our next talk. But the question was, and this is kind of directed at you a lot, can you speak to how the CDK has actually been adopted internally within AWS, and whether it's been a dog-fooded product or whether it's sort of still, shunned as more of a oh, well, this is going to be for our clients, not for us directly?
So again, I told you guys a little bit about this, the origin story and how we kind of got it started, and one of the teams that we initially approached when we started the CDK was this internal teams that's part of what we call the Builder Tools organization. It's the internal developer tools organization at Amazon, and it serves all of Amazon developers. And this team was responsible to enable internal users to use AWS natively. And so that was the kind of best foot in the door that we can have at a very early stage of the project. And they were quite involved in what we were doing because they've had a CloudFormation-based framework for using native AWS, using AWS natively. And so they were quite involved in the project from very early on, and we try to make sure that everybody internally knows about the CDK. Obviously, Amazon is huge, so it's not that easy. But the thing that actually made a huge difference internally, and I think it's true for any, like we actually had a kind of like a killer app for the CDK. This internal team created a construct library, a CDK construct library, for the internal CI/CD system. Amazon has a pretty crazy internal CI/CD system. We're actually trying to externalize many of those components as AWS services, but still, the internal system it's been in development for 15 years now, and it's basically a tool that everybody at Amazon uses. And so this internal team created a CDK construct library that allowed internal teams to define their CI/CD pipelines using CDK. And that blew up, basically, because these internal pipelines, you can imagine what a pipeline for a standard AWS service looks like. Deploying to all the regions with integration testing and bake time and enormous amounts of alarms. And so what happened is that this internal library became the killer app for internal adoption. And once this library was released, we saw a spike in internal adoption. The internal CDK Slack channel has, I think, over 3,000 users just internally. And so there's a pretty vibrant internal community around the CDK, and it's very similar to the external community. Like we see the same type of enthusiasm and initiative, and people are sharing construct libraries. We're still not where we want to be. I think I met with Matt maybe a year ago or something, and he showed me some stuff that they're doing in Liberty Mutual. I think we're behind in a sense, right? Like we're not as evolved as you in terms of like internal sharing of constructs and stuff like that, but we're definitely going in that direction, and it's been really fun and very valuable to have that internal community yell at us every time we break something. And, like we actually get a very, very loud customer that's very, very close to our heart and easy to, not easy to satisfy.
Sure. Thank you. So Matt, why don't you talk a little bit more about what Liberty's been doing with it? What did your first initial adoption look like? And what were some of those struggles that you guys had at making this really an organization-wide standard for doing your builds and your deployments?
Yep. So my first encounter with CDK was, I'm going to say July last year. I've been deploying serverless solutions on AWS for a few years, but essentially, whenever we were trying to deploy a private API gateway with a custom OAuth2 ping authorizer Lambda, it was taking over 1,000 lines of CloudFormation template to do that. Plus, it didn't, let's just say API gateway has quirks that you need to rename deployment IDs and things to get it to actually deploy in CloudFormation out of the box. So CloudFormation with serverless was painful on day one. Now, I know Eric's probably busting to tell me that's fixed with SAM. But
I am.
Yeah.
It is fixed with SAM.
Yeah.
I'm going to share my screen right now. No, go ahead.
Yeah, but that's the, remember this was last year. And basically, I took a couple of weeks and I rewrote our internal process into a construct library that I could share internally and reduced it to something crazy like 14 lines of code. So developers went from having thousands of lines of CloudFormation that they were either getting from somewhere like Maven because it's too much to just pass about, to, okay, let's pull it in via our internal NPM and let's just get it deployed. So that was where it hooked me, and I went, this is something that'll be amazing for Liberty that can transform how we deploy software. But from there, we then needed to create the environment for the developers to actually use it. And we've never once said you have to do it. That's the key thing here. We've just said, if this works for you, go ahead and use it. But if it doesn't work, SAM is an awesome option. Serverless Framework's an awesome option. CloudFormation's an awesome option. Terraform's an awesome option. But what we're talking about is, what is the fastest way we can get the business value deployed to production? That's what we care about. And that's why there's an awesome team in Liberty who are called the Accelerator team, who hopefully are cheering about now for their name being mentioned. And they've created a framework that Elad's seen it. I think I showed it to him. But essentially, whenever developers are creating their entire CloudFormation or their CDK stacks, their abstraction, you can go in and share it with anybody else in the organization. So you can actually, it's a bit like SAR for CDK, only for Liberty Mutual. And
SAR is?
Serverless Application Repository.
That's right. It starts with serverless, and then there's an application and a repository. But yes, no, that's a good layout. So
yeah, and so that's the thing. Taking that approach of enabling the developers, as well as using CDK patterns to say, okay, here is how you can use it, and this works with all of our technology that we have created for you, I think has really been our approach, as opposed to mandating anything or any other approach.
Seeing an otter drink a giant amount of Diet Dr. Pepper out of a huge mug is always going to put a smile on my face.
That's right. It's not something you see every day, that's for sure. So, hey, I want to take a moment. Thorsten, if you've got a minute, I know you're helping us host and stuff like that, but what are you doing with CDK?
Yeah, so I'm, first of all, contributing a lot to CDK. So this is one of the things I really loved. So I got hooked up with it. Okay, it's really great. This is the future of infrastructure as code. So I dive deep and tried, okay, this is missing, so I'm adding it. And before I knew, okay, there's this kind of ranking on GitHub, and there's a very small number next to my name, so why? So I'm very on top of the things. So, and then I added more and more constructs. So I was really happy to see the AppSync talk, because that's one of the things I initially wrote. Now it's a lot better, but it was my first code. And so this is what I'm doing with CDK. And now I'm going all in, consulting my clients on doing infrastructure as code, and then doing it using CDK, writing libraries for enterprise compliance, things like that. And yeah, for the community, as I'm one of the community heroes, so community is always my thing. So doing the CDK happy hour and the German CDK happy hour, and managing all these things to bring the community together for these things. So I'm really happy to have this CDK day, and it was, no thinking, sure, I will join.
Awesome.
So one thing that I think a lot of people wondered, at least I know I did, was the CDK and Terraform. You know, these in a lot of ways are sort of competing products. Their goal is to make the infrastructure as code, a nice painless sort of thing. So where do Mishra and Sebastian, where do you hope to see this Terraform CDK go in the future? As it's, still fairly early stage, but are you expecting, or do you hope that it replaces anything with the HCL, or do you really see this as a side-by-side fit?
I guess Sebastian can talk about the particularly to the project itself and the goals that we have for the project. But as part of HashiCorp, like, this is the way we look at it. I think I presented in the keynote that one diagram with Terraform is kind of the platform, and there's many entry points. So, all of these, like, we want to enable more and more entry points as they become available. We've always been that company. I don't know if you've used HashiCorp projects, from Vault to Terraform to Console. There's many other projects that we do. And actually, we're going to announce two new projects coming HashiConf soon. The interesting thing is that, we always really lean heavily in enabling the ecosystem and where the users really want to take the project. So I think, when Elad and like kind of the AWS CDK team came up with this idea, it was a pretty obvious thing for us to do. HCL is still going to be, our, I guess kind of the main front door into Terraform. But I think CDK for Terraform, as it matures, we'll see the community, where the community is kind of, going towards and kind of understand the popularity of the project. And then based on that, make decisions for the roadmap that will, just make it better every time. I know Sebastian and I have particular few different goals with the project right now. We're adding new languages and so on, and we have a really thriving open source contributor community as well. There's been a lot of good contributions from the community, which is not coming from me and Sebastian. So it is a good indication that people are finding it interesting, and just enables you to do things in a way, like kind of a very concise, familiar way that that you've been using in your day-to-day lives as a software engineer. So yeah, that's kind of the perspective from our side. I don't know, Sebastian, if you want to add something.
Yeah, sure. So so for me, it's really short term. It's mostly about stabilizing what we have at the moment and maturing, around the existing things we built already. But more midterm, long term, I really hope that we can cater to more complex use cases and also get the community involved into building abstractions. I think abstractions are in the end what it makes really valuable. That's what's really valuable about the AWS CDK as well. And there went lots and lots of work into this. So I don't think we can provide this out of the box at the moment. I will have a talk later where we'll talk about this a bit, what the options are at the moment and what the options might be in the future. But yeah, so having done a large migration projects for 2 years, one project, and I was really missing something like the CDK or something like CDK for Terraform. So the software engineering background, it's just you are used to so many awesome tools that you can use on a daily basis. And I hope to bring this to the Terraform community.
Awesome.
All right.
So we got about 5 minutes before we go into our next talk. I did want to have Elad talk about one thing in particular, because this is an issue that seems to come up a lot within the CDK forums and the communities, and I often see it being sort of unfairly used to throw the CDK under the bus. And I want to make sure that it's addressed here regarding dependencies, the version changes, and breaking changes within the API. One thing that happens very common is someone will be working on a CDK module, they do an npm install or an install of a new module, and all of a sudden things break and won't compile because we have a version mismatch between the modules. Can you talk real quick a lot about what the future roadmap is for resolving that issue?
Sure. I'll start from the end, and then I can talk a little bit about why we got here. But basically, we're planning a V2 of the AWS CDK. And the two main things the V2 is going to do is actually we're trying to not do anything to make sure that migration is not too hard, is solve the dependency problem and solve the breaking changes problem. So basically the goal for V2 is to, first of all, stop publishing experimental APIs that are not opt-in. So once you will if you want to use experimental APIs, you will have to explicitly opt in to use those APIs. We're still not sure whether it's going to be per API or globally or feature flags, or we're not exactly sure about the mechanism, because in terms of breaking changes, we're really working very hard, and we have a lot of tooling to protect us against breaking changes in stable modules. The problem is that the CDK currently contains multitude of experimental modules and multitude of experimental APIs within stable modules. And so as a user, in certain languages, actually, it might be super easy for you to use an experimental API and then get broken in the next release of the CDK because we decided to change the name and we were like, this is an experimental API, we can play with it. And so we actually want to make this way more formal, way more strict. And we want to enable people to just opt out, or basically the default will be to opt out from experimental APIs. And so ideally the breaking changes experience is going to improve. And the other thing is the dependency hell that we got ourselves into. And to be honest, it's basically, we just took the wrong turn. When we created the CDK, one of the first decisions we had to make was whether we vend the CDK in multiple modules or in a single module. And we actually took example from the AWS SDKs, which went the other way. Like if you are familiar with the history of the AWS SDKs, some of them originally started as a single monolithic module, and then started to break that apart because AWS got bigger and bigger, and the footprint of the SDK is actually important, right? Like if you run the SDK within a Lambda function or in IoT devices or things like that, you actually need them, or web, you actually need the minimal amount of code to be downloaded to the device. Time. Anyway.
No, just time. Smaller. Yeah, I was emphasizing small in the smaller, very, very important.
Yeah, exactly. It needs to be smaller.
Yeah.
The CDK doesn't actually have these constraints, right? Like CDK is mostly a build time tool. And so if you download, even if you download 20 megabytes of worth of package in order to, during your build process, it's actually negligible. And so what we're doing in V2 is we're basically combining all of the CDK into a single library. You're going to have a single dependency, and there's not going to be any problems because it's monolithic. So basically a library would just say, I need the user to bring CDK version 2.35 and above. And then only the application would bring the dependency, and we're going to have a single copy of the CDK in the dependency graph. Hopefully it's going to improve load time, install times, and things like that. And we actually already have a prototype. Our internal users are already starting to use this. So we're trying to get that out there. I can't really commit to a date because you guys all know how software projects work. But we have an active implementation plan, an active RFC that we're working against, and so hopefully that's going to come up within the next few months.
All right.
Thank you.
With that, yeah. Sorry, Matt. I'm talking over you. I have the otter suit. I'm more important. So, I'm just kidding. My mitts are off. Hang on a sec. There we go. I'm all paws again. So. I'm adding in Charles here. Charles is going to be taking on our next session. Say goodbye to some of our others. Thorsten, we'll see you later. And Merrick,
thank you, everybody.
Yeah, Sebastian. So what we're going to do is we're going to translate this over to, or we're going to transfer this over to Charles, and he's going to be taking on the next session. And with that, we're out of here. Have a great next session.
Awesome. Thanks for the intro. Thanks for everyone for organizing. Thanks for all the awesome libraries and projects. So I'll be talking about the CDK for Terraform. I am just an early adopter, sort of just getting started really, but I thought it would be good to get this sort of end user perspective. I've really been enjoying the project. Again, just special thanks to Sebastian and Mishra and everyone who's made the CDK for Terraform possible. So yeah, just a little background on the project. I'm just kind of getting started on my day here in San Francisco, so apologies if this has been covered already. But CDK for Terraform has been out about 2 months. Still considered alpha, I believe, but we're using it in production at my job. I work for ShopStyle. We're part of Rakuten, great place to work, great company. We've got about 10 CDK for Terraform stacks, but we're very highly invested in Terraform. We have hundreds of Terraform stacks. But yeah, we're using CDK for Terraform in production, and it's really going very well for us. So what I'll be talking about today is what brought us to this project, what brought me in particular to CDK for Terraform, some of my background on this project. I'll be doing some sort of live coding examples, kind of getting set up. And I will probably spend most of the time on that, talk about, some sort of minor issues that we've had, sort of things that we've overcome. If I have time, I'll talk about some of the cool stuff that we've done and sort of like project setup, use cases, and hopefully have some time for questions. So I'll be doing an example in Python just because that's what I'm familiar with. But as probably know, the CDK framework based on JSII, I believe, allows these projects to be written in different languages. So I'll be using Python, but TypeScript is also supported by CDK for Terraform, and more languages are likely to come. So with that, I will talk a little bit about sort of why we're interested in CDK for Terraform. As I mentioned, we have hundreds of Terraform stacks that were built in HCL, and HCL is not exactly intuitive. I think it's gets the job done. It's a superset of JSON, and reading it, working with it, editing it is can be difficult at times. It definitely gets the job done, but it is certainly not as friendly or familiar to most people compared to your average your favorite programming language. So our experience with infrastructure as code kind of started with CloudFormation. We were building out VPCs and sort of the early days of CloudFormation, even before JSON or before YAML was supported, doing it all in JSON. We ended up doing some infrastructure as code with SaltStack, which worked okay, but is always sort of lagging behind the support, because in SaltStack, you'd have to write a lot of Python code, basically, or somebody has to write a lot of Python code. You end up sort of modeling things in YAML, running it through Jinja, but it was always lagging behind features. And then we ended up switching to Terraform, I think even before the workspaces feature came out. So we ended up writing a lot of custom tooling, running HCL through Jinja, and it definitely got the job done, but again, certainly not as elegant as, say, writing Python code. So kind of where we are now is using Terraform more as an engine and not a language with or a DSL with HCL. And Terraform's awesome, and it's really fast. There's tons and tons of community support, lots of coverage basically for various cloud providers and various sort of backends or things you want to automate. And we find ourselves sort of looking under the hood less often. We can model our infrastructure in Python and obviously reading Terraform documentation, but really dealing with the ins and outs of Terraform less and less, which is kind of nice. And I really think that Terraform's CRUD model for building out new providers is really awesome. It's something that you don't really have to deal with as an end user, but I think it shows that as AWS and other cloud providers come out with new features, Terraform is really fast to support those things. And again, from an end user perspective, this Terraform for CDK for Terraform allows us to sort of follow existing development patterns. We can write unit tests, do CI and CD, following existing patterns that we follow on other projects. So that's great. So with that, I'm gonna get started on a example. Again, this is just going to be pretty simple, just what it might look like to get started with the CDK for Terraform. So I'm going to have a couple terminals open, and the first thing I'm going to do is create a directory. Nothing goes wrong. It's always kind of nerve-wracking to do some live coding. I'm gonna just search my bash history for the command, and I'll show you that this is going to create a new project. Obviously, I've already installed Terraform. I've already installed CDKTF, CLI. I'm going to create an example project. It's going to take a few minutes. This is using a Python template and local state. If you take the local flag off, you'll be prompted for Terraform Cloud integration, which is really nice for managing state. You can also use a variety of Terraform backends. So I already have a Python virtual environment set up. And what's happening right now is CDKTF is reaching out to the AWS Terraform provider and building it dynamically. I was just going through this example last night and realizing that we've already switched to pre-built providers. So it's really much faster. You don't have to sort of build this out dynamically. So we'll get the templates updated. But if you find a provider that is not pre-built, you can always do this this step. So while that's running, I'm going to kind of show you how I develop. If I had an IDE set up, this would be really nice, but I'm kind of old school in that I just use a Python shell, and I tend to kind of tab complete to figure out libraries and how they work. So I'm going to import this pre-built provider that I already have set up. So I've imported that provider, and I can start to see what classes are available by just tab completing. Tons and tons of AWS stuff. So for this example, I'm going to set up an S3 bucket with static website hosting. So let's get the help on S3 bucket. There we go. There's the doc strings that are sort of automatically set up, and I probably have this command that's completed in my other terminal. So you can see my project is set up. I can do ls. I've got some nice friendly help that's been printed out, and I have an example project. Just to give you an idea of the layout, this main.py file is sort of my main stack. This cdk.out directory is going to contain the synthesized Terraform output. So the CDKTF actually just runs Terraform under the hood, and there's some other sort of scaffolding here as well. But I'll be editing this main.py file and working on adding an S3 bucket and static hosting. So let's see. Started on that. So like I said, I tend to kind of go back and forth between an interactive Python shell to kind of figure out how the libraries work. And you saw that I already imported this provider, the AWS provider. I'm going to just copy and paste that over here and get started. So I'm importing the S3 bucket. In the other window, I checked out the doc strings. So one other thing that I know I'm going to need is to set up my sort of AWS provider, defining things like my region. You may want to define credentials. I already have that set up. So let me get the doc strings on that as well. That is, here, see, AWS provider. All right, so we can do some doc strings on that one as well. As you can see, there's just tons of stuff. I know that I've done this plenty of times, so I know I need to pass in a region. I'm not doing any fancy stuff like assuming roles or anything like that. So I'll switch back to my editor and import that. And I'm going to just set it up. All right. So, yeah, I guess I can give a little bit more of an overview before I get too deep into this example. So, sort of the main entry point here is sort of the app defining a stack. My stack is a subclass of Terraform stack, and then kind of the flow of the application is just going to kind of go sort of declarative. From here. Just defining resources. Obviously, you can you have all the strengths of Python, more inheritance, classes and functions and whatnot. But we'll keep it pretty simple for this example. So yeah, so we'll set up the AWS provider here. We're mostly just kind of defining the name And as I mentioned, I know we'll need the region. I think I'll do US East 1. And then now we can start to define some resources, such as that S3 bucket that I mentioned. As I go, I'm just going to start synthesizing, and that means converting from Python to HCL. Let's see, what did I have? Oh, sorry, I think I have two copies of this open. Oh, that's an old one I was working on last night. Let me just get situated here. Yeah, so I'm going to start synthesizing from Python to HCL just to know that I'm not introducing, syntax errors and that sort of stuff. Oops. And this, could give me a stack trace if I had a syntax error, but luckily no problems there. So I'm going to just take a quick look at what was rendered out, and there's not much there, just kind of the AWS provider setup. So now that's working. I can start to work on my S3 bucket. And as I mentioned, we're going to kind of try to build out a static website. So let's see, we'll call this bucket. And what else do we need here? Probably the name. Oh, let's just check the docs, see what else we might need. I will note that I tend to go back and forth between the Terraform documentation to figure out sort of what's required. And I think that, and there's some open issue about kind of getting Sphinx documentation auto-built. It would be awesome if some of these required things, I'm just sorry, I'm just scrolling fast. Some of the documentation was in the doc strings. I'm sure that'll come eventually. But in any case, I tend to sort of cross-reference Terraform online docs versus Python doc strings. Okay, so in any case, we'll need an ID. We're going to want to specify a bucket name and so forth. So let me see if I can get this going. All right, so we specified an ID. We will, I mentioned a bucket name. I think I'm going to just use that in a couple places. So I'll go ahead and keep it dry and keep this going. So okay, test. That's not taken. Bucket equals name and region. So this is so. On. All right, region equals region. And let's see, probably missing a couple things, but I'll give it a try, see if it works. Synthesize that again, see if I have any syntax errors. All right, so I do have a syntax error, and I tend to, let's see, is there anything? I'm running the same stack through Python, and oh, I didn't specify the bucket name. It's going to give me a little bit better error. That should work now. Yeah, and the synthesize would also probably work now as well. So I should be able to run CDKTF deploy and create that bucket, but I know don't want to run out of time, so I'm going to just keep going. So I have the S3 bucket, and I mentioned I wanted to do static website hosting. So that is, if I search the docs for website, I can see that there's a couple things. Website domain, the website is passing in a reference to an S3 bucket website. So that's actually another class. And I'm going to read the docs on that. So here we have S3 bucket website. Notice that I'm not going to pass in self. I don't think I need to specify an ID, but I'm going to specify an error document and an index document. So I'll switch back to my editor, import that class, and get started defining that. So S3 bucket website, I mentioned error document. I'm going to call that error.html. We're not actually going to use that. I'm pretty sure it's a required argument though. And index, just double check the doc. Is it index document? Yeah, index document equals index.html. And now I think this is probably going to need to go above. Yeah, this is going to need to go above, right? So here, and website. All right. Now I can pass this website configuration in to the bucket. All right, see if that synthesizes. Awesome. So that synthesizes. I feel like I'm making a lot of changes and hopefully this is going to work. But I did want to also upload a document. So let's do that. Let's add index.html here. Say hello CDK day and upload that. So that's going to be another import. So that's going to be S3 bucket tab complete object, right? Get the help on that one and see how that one works. So we're going to upload, specify a bucket, specify a key name, and that sort of thing. So let's get started on that. I'm going to need to import it. S3 bucket object. And so after we create the bucket and configure the website, static website hosting, we're going to upload a bucket object, basically a file, uploading a file to S3. So let's try that. So we're going to just sort of identify this as the upload. That's kind of identifies, these identifiers end up in the HCL. Could basically be anything. And we're going to say bucket equals bucket name, is where it's going to get uploaded. And the region. And also we're going to need the key, file name. Let's see what else. Oh, ACL. I think we'll need an ACL public read. We need a content type, I believe, as well. Type is text HTML. And in Terraform lingo, or Terraform specific, we're going to want to specify that the bucket should be created and be available before the file's uploaded. So that's depends on, and we're going to say bucket, although I don't have that as a variable, but I'm going to come back and add it. So let's try that, bucket. All right. This should work. Let's give it a try. So synthesize it. I could just straight deploy it, but we'll check. Oh, I got a syntax error somewhere. So let's see if I can hunt that down. Oh man, where is it? On line 22. 22. I don't see it. I'm not on line 22. So region. Line 22 in the net. Syntax bucket name region. I don't see it. Oh, got an unexpected argument region. Init got a region. This one? I thought oh, it's a bucket object. Yeah, okay. So they probably don't need that here because the bucket's being created. And then that again. Okay, cool. So that's synthesized. And let's try to deploy. So CDKTF deploy should create the bucket, configure the static website hosting, and upload the file too. So this will take a couple, minute or two. Like I mentioned, Terraform's pretty fast. You get a little example output there of what's going to happen. Yes, I want to do that, so we'll follow through. Oh, I don't think I specified the source file name. Oh, and it already exists. Wait, what? Bucket name. Let's try a different bucket name. I think I'm also remembering that I want to do, I want to read in the file. So that's going to be source. It's another argument equals ... index.html. And there's the ... because Terraform's actually running in that CDK out directory. So it's going to have to go up a directory to find that index.html file. Let's see if this works. I'm kind of running out of time, but hopefully leave a couple minutes for questions and answers and chat a little bit more. All right, so it's going. You can see here that it's deploying the stack. Yeah, while it's kind of running, let's see. Yeah, so that created. And one other thing, so you don't really get much output of like what's happening, but you can bump up the log level and rerun that. And one more thing I'm just going to do here is add a Terraform output. So that would be, Terra. And sort of just kind of printing out a lot more information here. So it's going to be self, call this the website endpoint. And this is going to be value equals bucket, website endpoint, I believe. So I'm going to really bump up the log level and we'll print out the URL. As you noticed that I ran Python earlier just to kind of get a better stack trace. You can also CD into that Terraform, so the CDK out directory. You can run Terraform directly. So you can run Terraform plan, Terraform apply. You'll get more output there. Oh, did it not give me a? Not give me my output. Did I not bump up the log level? Oh, I didn't bump up the log level. So we're actually, I've been using, I'm very familiar with Terraform, so I've been still running Terraform a lot, but I do like the CDKTF CLI. So you get nice colors, you get these sort of spinners, it's very friendly, but ultimately it's kind of, very much compatible with the Terraform CLI. So I have tons of output here. I should have my endpoint URL here. I'm just going to copy and paste that and show you. Hopefully the website is there. Very simple. Oh, cool. It worked. So there it is. It's a pretty simple example of getting started with CDK for Terraform using Python. That's all I really have to show here as far as the Python examples. I will just take a couple minutes to kind of wrap up. If there's any questions, I will switch over to chat and see if I can field any questions. As I mentioned that, we're still kind of getting started, but we've done a lot with it so far. We've automated Redshift, we've CloudFront, working on RDS, databases, VPC, security groups, DNS with Route 53, lots of IAM stuff. We've been working on integration tests, so running the synth, running plans, checking for drift as well. There is a lot of potential here for the project. So, I see, the possibility of sort of reusing code between CDKTF and other, Python projects that we have. For instance, and we're hoping to sort of open source this WAF automation framework that we wrote. And just the other day, I was like adding a a static WAF rule, and got some PR comments like, hey, what about these allow lists that you have over in our auto blocker project? And well, the auto blocker is written in Python, and we can do our WAF rules in Python as well, static WAF rules in Python. All of a sudden, like that compatibility layer is there for us, so it's super exciting. So kind of running out of time. I can see if there's any questions. I think it's something like CloudFormation include. Not sure about that one. Yeah, let's see. I don't think there's any other questions here. There's a note about sort of complicating things, loops and conditionals. Yeah, I mean, the example that I went through is pretty simple, but kind of some of the other cool things that we've done are kind of like setting up our Terraform state. I mentioned, you have all the benefits of Python. So if you think back to the example that I did with sort of an example stack. So one thing I have sort of, we call it a shop style stack, where we can inherit our shop style stack, set up our state. We're reading in. I did some work to have sort of like a reusable data stack where if there's a YAML file, a YAML config file in each stack, we'll read that in automatically. We have sort of like more of a global a YAML config where we can define things like Amazon account IDs, VPC IDs, some things that are sort of built out in other places, just to kind of get started with scaffolding. We also, I think it's kind of interesting to decide what are you going to do in Python versus sort of like what are you going to do in Terraform data lookups as well. We can also have all of the flexibility of Bodo, so things like, again, just reading in an Amazon account ID or other things that might be defined, before you get started with this project. Super flexible there. Yeah, so I'm kind of out of time. Doesn't look like I have any questions here. So if turn it back over. And thanks again to everyone for making this possible.
All right, Charles, thank you so much for that talk. One of the things that it always comes up a lot with any of these projects is where's the Python code? Where's Python? People really love Python as a language, and it's always sort of a second-class citizen in some way. So it's really awesome seeing you do that demonstration. Thank you so much for that.
Yeah, my pleasure.
We appreciate it.
Yeah, absolutely. I wanted to introduce the next speaker. So the next speaker will actually be Sebastian, who you saw in the panel and earlier on during this conversation as well. He's actually going to be talking a bit about how you can exchange constructs between CDK, CDK Terraform, and CDKs, right? Or CDKs, or however we want to pronounce that. Yeah, so I suggest we switch over to that and listen to what Sebastian has to share.
All right, let's talk about mix and match CDK constructs. I'm Sebastian Kaufmann, and I'm the core maintainer to the Terraform CDK. You can find me on Twitter under @Kaufmann. Yeah, let's dive into the CDK ecosystem, which consists of AWS CDK, Terraform CDK, and CDKs. And they have all one thing in common. They're built on the JSII and constructs packages. But they all have different implementations when it comes to the applications and the stacks and the actual abstractions, if there are any. And today I want to talk about using constructs from one CDK with the other one. So like sharing abstractions across the different implementations, basically. And by constructs, it's like one thing important to remember is level 1, or like the different levels were introduced and coined by the AWS CDK itself. So level 1 equals to the generated layer. Level 2 are like abstractions based on those generated constructs, and provides intent-driven APIs. Like easier to use classes and objects, basically. And where level 3 really equals to like patterns and broader usages, such as a load balance target service, for example. And while
the AWS CDK has all these abstractions. CDKs has a few abstractions, I believe, CDKs Plus. And the Terraform CDK at the moment doesn't really provide any out of the box. But of course, you're free to build your own. And I think there are like a few community-driven approaches perhaps, but out of the box, we don't provide any at the moment. And yeah, we would love to leverage what the AWS CDK has built in the Terraform CDK as well. But long term, it could also be like the other way around. It would be quite interesting. And the general problem here is that each of those products are like individual implementations, and they're not really compatible, and they all synthesize down to different configurations. Like the CloudFormation spec, or the Terraform spec, or the CDK's manifest spec. Yeah, and how to tackle this? Let's start with the interop between CDKs and other products. And I don't necessarily only mean like CDKs, but in general, like all of them, like, like whatever you have basically. And I think it's like an easier story in this case, since it's more natural to have it like sequentially applied. So you provision whatever infrastructure you have. It might be in AWS, it might be in Google, in Azure, it doesn't really matter. And then CDK comes into the play, and you just synthesize your stack and apply it to the configuration which you have. I think this fits probably most of the use cases at the moment. But perhaps there's even an integration story between CDKs and Terraform CDK. Since there is a Kubernetes provider, and you can actually deploy manifests with that Terraform provider. And so I could imagine something where you have like a Kubernetes provider, driven by CDKs, and you leverage infrastructure which you provision with the AWS provider for Terraform, something like this. This might be interesting, but I haven't really deeply thought about this yet. What I've been thinking more about is the interop between AWS CDK and Terraform CDK itself, since I'm naturally interested in this. And the specific problem here is really the CloudFormation and the Terraform AWS provider syntax are different, right? So it's like different configuration, different formats, even though in the end they are provisioning the same resources. So how can we tackle this? The current options are already existing basically, so not really very integrated, but you could totally go ahead and use the AWS CloudFormation stack resource in a Terraform setting and apply whatever you synthesize via your AWS CDK stack, for example. So it's not really a great experience probably, but it would probably work. And vice versa, there is like an open source project which provides custom resources for Terraform providers. I haven't really tried it out yet, but it looks sort of interesting. I'm not sure how stable and how serious this is, but that's at least something which could work in theory if one was, really serious about trying it out. But again, that's not really something which we are after. I've been talking to Elad, one of the core maintainers of the AWS CDK team. And he actually had a great idea, and he came up with a prototype, which I would like to show. And it's like a Terraform stack. So like in the Terraform CDK and Terraform stack, which is using a native AWS CDK resource, and the AWS S3 resource in this case, which comes from the Mono CDK experiment package, which is essentially like a pre-release for the anticipated way of distributing packages for the AWS CDK in version 2. So like, everything is one package. Then not really important in this case, just important to remember, it's a native CloudFormation resource. And we actually just provision this inside the Terraform stack. And not as you might expect through a CloudFormation stack resource in the Terraform provider, but actually as a native resource. So when we do a CDKTF diff, we do have native Terraform resources which were provisioned by the stack which you just saw. And that's quite awesome. So how does it work? It's a manual mapping layer at the moment. And I said it's a prototype, so I believe it's pretty much exactly this example which works, and all the other resources aren't working yet. And so the idea is that on level 1 layer, so this generated layer which we talked about for CloudFormation and Terraform, on this layer we have a mapping where we map attributes to the other system, like from CloudFormation to Terraform and vice versa. While this could probably be done, like in some way, to some extent, automatically, I believe there's still like lots of manual work involved. And that's actually the catch. So it's like when we just saw like 2 or 3 resources which were sort of working, there are like a bunch of resources, more than 750 resources which aren't working yet. And that's where community comes into play, and that's what I like to pitch today. So you're looking for help if you're interested in contributing into this. There's a project, just follow this link and it will take you to the project. We're also around in the Slack, so just talk to us there if you're interested in that sort of thing. And the real gain is not only for the CDK ecosystem, but in the end, it would be like a native CloudFormation to Terraform and vice versa generator. So you could take any CloudFormation stack and transform it into Terraform. And at the same time, it could take any Terraform AWS configuration and build a CloudFormation stack out of this. So this would be quite cool, I think. And yeah, again, if you would like to have there, you're looking forward to see you around. And yeah, thanks for having me. And
all right, excellent.
Yeah, very cool. The idea of being able to create, like one set of definitions and be able to use them with whatever you want. I think that's a really great idea. I can't wait to see where that goes in the future.
Yep, I agree. Very compelling stuff. So we're going to move on here. And man, I'm going to just apologize straight up front. I'm going to work my best on the name. It's Chitranjali Edpuganti. Man, I'm really trying. So, but she's going to be talking about auditing your account resources across organizations. So with that, let me pull this up here. My transition wasn't as smooth today, but we're getting there. So bear with me, and here we go.
Hello everyone, hope you're having a great CDK day. Today I'm going to talk about AWS Config setup with CDK. Let me brief you about what AWS Config is. Config is a fully managed region-specific service which lets you audit the resources across your region and logs the changes to S3 bucket and also notifies you regarding the same. It's mainly used for audit and compliance purposes. Let us suppose you have an EC2 instance which has gone down today and you want to track what has been changed from yesterday to today. You can go and check the logs and also revert to the previous configuration if you wish to. It also lets you track the relationships your resource has. Like I want to delete an elastic IP and ensure that it is not attached to any of the EC2 instances. I can go and check my config for the relationships and also which ensures safe deletion of the elastic IP. Let us go and check how to set up the config on the dashboard. So this is how it looks like. To set up the config, you need to choose what resources you want to audit. If it's all resources, you can check this. If you want to go for specific type of resources, you can choose those. And you need to specify an S3 bucket where you want to store all your configuration logs, right? Change logs. So you can also select an SNS topic to act as a delivery channel. This is purely an optional step. This will notify you every time a change happens. in the logs. And also you need to have a config role. This is a service role which lets config to have read-only access to all the resources you want to track, and also have write access to your S3 and publish access to your SNS. Right. Next, let's skip the config rules for now. So once you confirm, the config will be set up in this region. So the dashboard looks like this after that. So here we are tracking all these resources. So every time a change happens, it writes it to the configuration timeline. You can go and check that. And this is the S3 bucket where the logs are going to be stored. Since this is region specific service, you have regions as logs here. So let us assume you want to ensure certain standards across all your tenants. You want to make sure that logging is enabled on all the S3 buckets across all your tenants. So for that, you can have these rules deployed into your config, which tracks all the resources and gives you a report of non-compliant and compliant resources. So I have enabled S3 bucket logging enabled rule here. So this evaluates all your resources and gives you a status about which are compliant and non-compliant. If you go to the compliance timeline, it lets you see on which date it's non-compliant and which date it has been changed. All the change logs you can see here. And as told, you can even check the relationships. This is the logging bucket which has been enabled on this. Right. So AWS itself has a few managed rules which you can use. If you also want to build your own custom rules, you can use RDK, Rule Development Kit, to build your rules and deploy it in the config. So this is how the automation looks like. You have an CDK app, which is Config Auditor app. You can deploy in your central account or dev account, and this will set up the config in all our target accounts. So it assumes a role and in your target account and checks if the config is already set up. If not, it will go on creating the S3 bucket and SNS topic to act as a delivery channel, and it also turns on your configuration recorder. So once this setup is done, you can have your rule stack set, which will ensure these rules are deployed into this particular target account, right? So this is how the code looks, the CDK app. Here, most of it is a boilerplate code, like when you do CDK init. Let's go to the starting point of my app. Here we have this stack. This is a CloudFormation stack which we are going to deploy. So here you have this env variable. This will take region and account ID as variables. So you can give those two which deploys in these account and this region. If you don't specify anything, it will go for the default region which is applicable to your role. And if you want to give environment variables, this is the place you can give it as a dictionary here. And this is how my stack looks like. So I'm using Lambda construct to deploy my Lambda here. So all my reusable code will be going into a layer here. So this layer, I'm attaching this layer to my Lambda, and I'm also giving my Lambda assume role permissions. So I am attaching the policy to the Lambda role. This Lambda role will be already created. You need to attach this policy here. So let us go to my Lambda code. This is the folder where all my Lambda assets will be. If you go and check this, here I'm creating an S3 bucket. So I'm using only one bucket for the entire account, and you will have to create an SNS topic to set up as delivery channel. So once I'm setting up the topic, I'm going to set up a config recorder also. So then delivery channel setup, and then we will start the config recorder to check the logs. So once that is done, so when you do a CDK sync, your app, all that app will be changed into this CloudFormation template. You can use this for your local testing if you want to. And once you build your app, you can use this build spec YAML and build your code pipeline using this and deploy your CDK app here. So this will deploy the app in the region and account you specify here, right? So once the app is deployed, it will start going to the target accounts and creates the config setup there. So this is the same automating the process, which I explained now. Now, once the config is set up, you also want to deploy the rules. So you can select all the rules from AWS managed ones. And also if you have any custom rules, you can package everything into a stack set. And you can update this stack set with the target account ID. So which will create a stack instance. That means all those rules which is in this stack will be deployed on our target account. And so once the stack set has been deployed, all your rules with config is set up into all your target accounts. So this is how we are setting up config. So that's it. I'll drop a link for the GitHub repo if you want to take a look at it. And thank you so much for joining me. Have a great day.
All right. Well, I'm going to tell you honestly, my computer is circling a little bit. Thorsten, are you there?
Yeah, I'm there. Everything's fine. So thanks for this great talk about AWS Config. I will definitely try this out because setting up config is not easy, and with this, it might be getting easy.
All right, I seem to be back. Thank you, Thorsten, for jumping in there. So on our next one we have queued up here is going to be Andrew Wynn. I learned how to say that this morning on moving from CloudFormation YAML to CDK. So with that, I'm going to bring that up, and here we go.
Hello, wonderful people. My name is Andy Nguyen, and I'm a software engineer that works at Liberty Mutual, a global Fortune 100 insurance company. Welcome to my presentation, moving from CloudFormation YAML to CDK, benefits, how to do it in a production system, and more. We've got a lot of amazing content to go over in 10 minutes, so let's jump right into it. Now, whether you are new to infrastructure as code, or you are an expert in AWS CloudFormation, I would highly recommend creating new infrastructure with AWS CDK. AWS CDK has several benefits over its AWS CloudFormation predecessor. One, you write and maintain a lot less code. Here's some examples from some projects that are delivering value to users in production. These projects were initially written with CloudFormation YAML and have since been migrated to AWS CDK. An AWS API Gateway, which was previously 274 lines of CloudFormation, is now 31 lines of CDK, 88% less lines of code. A best practice asynchronous Lambda project containing AWS SQS, AWS Lambda, and AWS SNS was originally 342 lines of CloudFormation. This has since been reduced to 107 lines of AWS CDK, a 68% reduction. Note that this CDK migration was done simultaneously with a feature enhancement, so most likely the older CloudFormation number should have been higher here, and we should have seen a higher percentage here as well. We also see similar improvements with other services, such as AWS Fargate and Amazon S3. 2, you can maximize the potential of your developer tools across the entire developer toolchain. For example, IDEs, and yes, this also includes you Vim folks out there. IDEs were made to work very well with programming languages, CDK, and not necessarily a custom language defined in YAML or JSON, CloudFormation. These IDEs can help provide auto-completion, built-in documentation, and other automated recommendations to not only speed up, but also clean up your infrastructure. There's also other benefits from writing infrastructure with programming languages. They bring compiler errors to your local machine. You hate to see those red squiggly lines, but they provide early feedback loops to make sure your infrastructure is valid as soon as you write it, instead of noticing everything breaking after all the code is written and then later being sent to the cloud. Flexible abstractions are here as well, being able to leverage the power of programming languages while still having an API that allows you to fine-tune resources for your use case. Leveraging the simplicity of using abstractions while not being locked into our particular type of abstraction makes writing infrastructure a breeze. Dependencies. With CDK, you can leverage the power of existing package management technologies, examples including NPM, Maven, pip. These systems are global and have stood the test of time. Leveraging these dependency tools with your infrastructure allows you to build on the foundation of already written best practice open source and internal infrastructure. Support. You are creating resources on the AWS platform. It goes hand in hand to use an AWS infrastructure tool. You have the large online community of AWS users to gain knowledge from, as well as the official support channels provided by AWS themselves. 3, skills and motivation. There's also a psychological aspect as well. Being comfortable with AWS CDK means being more confident and skilled with at least one programming language. This means that you become a more well-rounded developer by being able to work with both infrastructure and programming skills simultaneously. It also allows you to onboard a wider range of developers onto your teams quicker, leverage the wider subset of people that either have more infrastructure knowledge or the people that have more programming language knowledge, and you can provide a maintainable growth to your infrastructure. The work that you do today will help you create more infrastructure more quickly in the future and will motivate your teams to create high-quality, reusable software. All right, let's go over how we can migrate from existing production CloudFormation to production CDK. For example, let's start with a project that we want to migrate that declares the following resources in CloudFormation: an SQS queue, an AWS Lambda that pulls from the SQS queue, and an SNS topic, which the AWS Lambda publishes to. Also, we will attach a publisher to the queue and some subscribers to the topic for inbound and outbound traffic. Our customers need to use our systems 24 hours, 7 days a week. So we run into the challenge of needing to migrate with zero downtime. To solve the problem of zero downtime, we can use a blue-green strategy, like the ones used in CI/CD pipelines. We take the strategy to move quickly while also having a backup strategy once something fails. Here are the steps. Create a new project where your new CDK infrastructure will be located. This process varies per company. Step number 2, create AWS CDK code that represents prior CloudFormation code in your new project. Recommendation here is to work backwards in your stack, which will allow for easier rollbacks. Step number 3, reconnect old resources to new resources. This includes data migrations. Step number 4, if you have more resources to migrate, go back to step number 2. Step number 5, retire the old project. And then step number 6, you are finished. Let's go through these steps with our example. Starting at step 1, let's create a new project. Step 2, we need to choose an AWS resource to move over. According to the recommendation, this would be the SNS topic. Step 3, we want to connect our new topic to our existing infrastructure. Because we already have subscribers on the old SNS topic, we may need to update the Lambda to support multiple outbound SNS topics until we have all the subscribers move to this new topic. Step 4, we just started, so we're going back to step number 2. Step 2, the next infrastructure we'll want to port over is our AWS Lambda. Step 3 will be straightforward. Connect your old SQS queue to your new Lambda. Connect your new Lambda to your new SQS SNS topic. While the Lambda was easy to move since it is stateless, we will soon see the differences when moving a stateful service, in our case, the SQS queue, but similar concepts would also apply to technologies like Amazon S3. Step 4, we go back to step number 2 again. Step 2, let's create our new SQS queue. Step 3, we will want to have our new AWS Lambda pull from our new SQS queue and have any inbound connections point to the new queue. When the number of messages on the old queue drains down to 0, we will be able to retire this old queue. For stateful services that might not automatically drain, like Amazon S3 or DynamoDB, we will want to move this data ourselves from the old resource to the new resource, usually following what AWS best practice recommendations are for moving this data. You would do so during this step as well. Step 4, we check our list of resources that we've migrated. And we've noticed that we've migrated all of the resources to CDK. So now we can move on to step 5, which is the cleanup step. Step 5, this is where we stop any old running CloudFormation services. We update any of the documentation. We update the code to make sure that it's not referencing any of these old CloudFormation services. And we move the old project into a README state. And then we're on to step number 6. We're done. Now that we've covered the benefits and have migrated a project, let's cover some things you may not know about CDK. The open source community for CDK is amazing. As shown by the AWS CDK GitHub page, the communication between developers from all different backgrounds have been the best that it has ever been. CDK is already a very useful product, but it'll only get better as more developers get familiar with the tools. And then there's also a concept of infrastructure paralysis. When you already have working infrastructure, there can be a hesitation to migrate to new best practice infrastructure tools. You are not alone. My teams have faced challenges of whether we should migrate certain projects now, or if it's a better use of our time to deliver on new features. The worst thing you could do is not having a plan. Have a conversation with your team and see where migrating old CloudFormation to new CDK fits in your product strategy. As a side note, when starting completely new, I would recommend going straight to using CDK. Before I go, I would like to thank my employer, Liberty Mutual, as well as the organizers of CDK Day for giving me this opportunity to present to you. If you have any questions or comments, you can reach out to me at my website, andyln.com, or through the CDK Day Twitter. Thank you for attending and have a wonderful day.
All right. Thank you so much, Andrew, for that talk. It was really amazing to see how you're using actually CDK at Liberty and how you've also evolved it over the years. Thorsten, who is actually the next speaker and what will they talk about?
So the next speaker will be Luca from Italy, and he will be talking about serverless IoT. And yeah, it will be great because I love working with Raspberries and things like that. And he will show a great application of using CDK with local devices. And I'm happy to hand over.
Thank you, Thorsten. Thank you very much. And for the next half an hour, I'm here to talk to you about what we have done with serverless and our CDK local development for devices. But first of all, who am I? I'm Luca Bianchi. I am Chief Technical Officer at New Experience and at Whiskey, which are two Italian-based companies. And moreover, I am co-organizer at Serverless Meetup and Serverless Days. This means that I love serverless. I have been awarded as AWS Serverless Hero recently, and I'm an AWS community builder. Please get in touch with me. These are my references, and you can also see my Twitter handler on my name in the video. So please get in touch with me, and we could discuss about that. Today, I'm going to talk to you about HVAC system, which means that we are going to talk about a customer that we work with, which is an Italian-based company that has expertise in heating, ventilation, and air conditioning system worldwide. It's a NADCA certified company. NADCA is the US organization that certifies system air quality throughout the United States. And my company, which is New Experience, is a company that helps other brands to innovate their products and build smart products. And especially in this case, we built Alizea Remote Air, which is a smart product that leverages Alizea expertise in duct and air conditioning cleanliness to build a completely new smart IoT product. Building a completely new smart IoT product means that we needed to project and to deploy its architecture. And this is the reason why I'm talking to you about this right now today, because this means that we had to build this kind of infrastructure, and we managed to achieve that using CDK. But we have a few components that I want to focus on, which are the client components. We had a number of sensors, such as pressure and temperature and humidity, CO2, particulate sensor, and so on, that needed to send data to the cloud. And then we also had local cameras that grab pictures of the duct status and send them to the cloud to a machine learning model. So we had to build a board able to collect this data and then send data through AWS IoT, and then be able to manage this data and make that available for standard REST endpoints. Today, we're going to focus on the local and edge part of the story, and we are going to see how CDK can help even in provisioning edge devices, because every time that we provision an edge device and every time that we build create an iOS IoT thing, we need to deploy even something in the cloud. And this is the part in which CDK can play a huge advantage. Just let's have a look at the kind of board that I'm referring to. What we mean with remote air board is a custom design board, but it is basically a Raspberry board. So it uses Raspberry Compute Module 3, which is the enterprise grade Raspberry version, and it can be mounted on a custom board. And we had to build a custom board because we needed a couple of devices to be directly wired connected to the board using E2C bus. Especially, we need to implement a multiplexer, an hardware multiplexer, to select the right channel before talking to the devices. Because with I2C, all the devices share the same address space. And if you have two sensors of the same kind, they are pushing the data on the same address. So you need a multiplexer to communicate and to choose between them and to enable the channel before collecting the data. This means basically, to our understanding, that we needed to build a custom board, and this custom board needed to have a lot of logic on board on the device. But also we had over-the-air sensors, which means that we want to monitor the air quality for a wide area, especially inside a mall or inside a huge company plant, in which we need to put the sensor, which are pressure, humidity, particulate sensor, and so on, across all the surface, across all the establishment that we are monitoring. So we needed over-the-air communication because we needed to make that cost-effective. So we couldn't provision a board, a Raspberry board for each one of these sensors because it would have been costed too much. But we planned to have this board acting as an edge gateway. And this is very important because my idea is that you cannot and you shouldn't send the data from the sensor directly to the cloud. This is great for your home or business purposes, or if you have a very reduced number of devices. But if you are covering wide plant, if you are covering a wide area with a huge number of devices, and in IoT, more than 10, 15 could be considered huge, but you can scale up to hundreds of sensors in the same environment. Having each one of them connected directly to the cloud is not a good idea. It's not a good idea for security purposes, because you have to enforce security on each one of them, and basically, since they are low-end and low-cost chipsets, you won't have the same security capability that you can have on more expensive devices such as Raspberry, or even dedicated board, or even industrial board or PLCs. And on the other side, managing the communication means also filtering the data, cleaning the data, which means that you have to duplicate a lot of code if you want to put the same logic on each one of the device. And so we had this board to collect and forward data to the cloud after having cleaned the data and send the data after having been packed also to use the cloud communication efficiently. The board is able also to, has also to implement some kind of retry logic if something is not going well, because we cannot take for granted that the connection will be always on, always available. Even because you can have some kind of outages for, say, a few hours or even a few days. And what is relevant is that a single customer can have many plants, and each one of them can have many sensors and a couple of remote devices. And we needed also to deploy directly into their account the solution, because data related to air quality, especially these days, is really sensitive data. It's really sensitive because it is stated, it is demonstrated that poor air quality can take to the spread of diseases. And so you have to be aware of not having a leakage of the data. And one of the main points that our customer asked was to having the complete stack deployed in their account. And we also needed to customize, to be able to customize the deployment and provisioning of a new device. We leveraged our architecture on AWS Greengrass. AWS Greengrass was presented a couple of years ago as a way to run Lambda function directly on edge devices. And recently, they have added also the capability to run containers. But Greengrass is much more than that, because Greengrass can provide a lot of connectors between different Lambdas and different containers in the same devices. So you can write and develop your Lambda in cloud and then shift that Lambda directly on the device to be run on the edge device. And this Lambda can also be marked as a long-running Lambdas, which means that they won't be stopped after execution. And it is great for long-running tasks. It is also great for managing streams of data coming to the device. And the Lambdas through Greengrass can also access local resources available on the devices. So it's a great technology, and it supports a lot of connectors to AWS services. It also provides MQTT channels to handle communication. MQTT is a de facto standard protocol for IoT, because it allows us to send small amounts of data in a high frequency directly between different actors in our network and even to the cloud. But let's consider a simplified version of the previous architecture that we have seen for the scope of this talk. And we consider an architecture with a sensor device and with a remote air board and the local business logic that manages data collection. It manages cleaning the data and packaging the data and sending the data to the cloud. An IoT topic which receives data from a thing, but consider that the data coming to that thing should be differentiated depending on the type of the data and on the type of the sensor. And then an AWS Greengrass core, which monitors and manages Lambda deployment and even Lambda updates over the air. This is very important because we want to be able to update our code as much as possible, because the device is not something that we control, is not something that we have in our AWS account, and is not something that we can have our CI/CD stack to roll out a new update. It's something that can be sent to a customer. It can be in any kind of venting or air conditioning system, even in a house or in a mall. And we would like to be able to directly access the board with not having to be there in place, to be able to update the code on that board. And for today's talk, we don't consider a connector and managing complex connectors except for IoT topic. Even this simple architecture require a lot of resources to be created in the cloud when we deploy a new board. And this is quite strange because we are deploying a new physical board, a new edge devices, but Greengrass requires us to create a huge number of resources in the cloud. That a deeper look, it is not so strange to understand, because since Greengrass has to manage a package of resources that belongs to that devices, which means certificates, it means IAM roles, it means policies to define what the device can or cannot do, and certificates are required to ensure authentication, because on the device we don't have a user logging into. So unfortunately, we cannot use cognito user pools or things like that on the device. We need a different way of authentication, and AWS provides us with certificate-based authentication, which is great because it's something that you provide to authenticate your login. But we need to define that in our thing configuration, and then we needed also to define a group and the device version, and a configuration of our device that we have to send back. And Lambda thinks about co-versioning of all of these resources. So provisioning a new device means that we had to run through a couple of steps. Some of them happen on the device, and some others happen on the cloud. The first step is device setup, which is the initial step, because it is something that we have to do to configure the operating system and install IoT and Greengrass libraries. Then we need to create a corresponding thing in the cloud, because we need to create IoT certificates, policies, and so on, to make that device being considered and being available as an IoT thing. Then we need to create all the stack belonging to Greengrass to provide the resources needed by the Greengrass group, which means that setting up a new device requires us to install the operating system. And we use Raspbian, Raspberry Pi OS, or Raspbian. That's pretty easy. But after that, after the bare install, we needed to provide Wi-Fi connection, and a startup script could achieve that result. But we started having problems because we needed to configure all the device stack. So it means the libraries, it means all the specific device configuration, but also cloud connection. In this sample code, we can see what means configuring Greengrass using Ansible. Ansible is great because it's a standard, but configuring Greengrass using Ansible is not something which can be leveraged. And it's an option. It's an option that to be considered, but it's not the best option that you have. Moreover, you have to provide IoT thing certificates. So you can install the bare system. You can use a bunch of Ansible scripts to provision the common libraries, and then you need to install to have a certificate. And creating a certificate is a classical chicken and egg problem, because devices need credentials to access AWS resources and obtain a certificate, which in turn enables them to access AWS resources. And so you have to find the best approach available to you. You can install certificate on AWS beforehand delivering the devices, which is great, but is quite naive. Then you can provision by trusted user or provision by claim. And then we are going to discuss all of these three options. And just-in-time provisioning means that you are not embedding the device into the certificate into the device, which is great, but you are embedding something else. You are embedding a small bunch of language which resembles CloudFormation, which is provided as a string in this JSON, which support the JITP signature syntax. And once the device connects to AWS and connects to the endpoints, the profile, the provisioning profile, is sent to AWS. And if a role is attached to IoT thing, and the policy is embedded in the certificate, the thing is created. It is great, but because it allows us to perform unattended setup, so no one needs to be there. You have just to provide a Wi-Fi connection to the internet. There is no need for any kind of external app, so no app companion, but the device is in full control of the credentials. So it's not as bad as having the certificate, the final certificate embedded on the device, but you are embedding something that has the power to ask AWS to deliver, to send back a certificate. Is not the best option in my understanding, and even on the security point of view. And configuring JITP is quite difficult because it's not so easy. You have to version to serialize as a string a lot of configuring. On the other side, you can build a companion app, such as the same that happens with Alexa and Echo. You have a companion app, you log into the companion app, you start building, calling a temp provisioning claim, and then on the app side, you log it with your user credential, and then you can authorize this request and make that available directly, firing from the app the request for the certificates, or downloading the certificates and sending them over Bluetooth to the device. This is great if you have a one-to-one matching between user and the device that are configuring, but it's quite unfeasible if you are working in an environment with many devices, because you have to configure each one of them one by one, and is not the best way to achieve that. Then we can see that security is enforced, because you cannot have unattended or unprevented access to the certificates, since the app companion is requiring the user to log into the system using Cognito and having an IAM role associated to that request. So when someone is asking for a certificate, it is an authorized actor in our system. Configuration is pretty easy, but it requires an external app and even user explicit approval. Then you have what is the so-called certificate-only claim, in which the device performs a claim, and you have a restricted set of credentials attached to the device, and then it claims for a certificate. The policy asks for AWS IoT, which in turn has its own policy to ask for a certificate. and then the certificate is sent back. It is great because it also is supported through MQTT, so you can push on a QTT topic, and you just only have to need the permission to push on that specific topic and have back a certificate. But you cannot perform unattended provisioning and even different multi-workflow and approval steps. The idea that you can build, and that we built using CDK, is building an AWS IoT vending machine in which the client has a public token which is sent to a backend, and the backend stores that token in an availability, in an enabling table, which can be authorized before or after the provisioning of the resource. And then only once that token becomes authorized, and it can also be authorized automatically through API, the Lambda invokes IoT to generate a certificate. When a match is found, Lambda invokes AWS IoT, the certificate is built and sent back to the device. It's a better solution because solves a lot more problems and gives you the flexibility to have a registry of your devices waiting for approval or being authorized. And this is for the first 2 points, because the other points of our list needs to be set up to be able to use Greengrass. And here is where CDK came into the play, because we were able to build a CDK construct that can be run locally from an host machine in the local network, or an host server in the local network, or directly from the device, that can execute code in the cloud. Remember that at this point, the device has an IoT certificate which is valid and allows them to run code in the cloud. So we can build the Greengrass group and Greengrass resources that we need. If we want enhanced security, we can have an external Docker container or server in our local network acting as a running point, an entry point for our CDK, and in which we can use CloudFormation instead of IoT APIs in order to provide a rollback and resources the deletion capability. And so we can write our stack to build core groups, Greengrass core groups, core logger, resources, and connector directly with CDK, which means that we can create the roles that we need, create instances in a new Greengrass role. Then we can create the core version, which is the basic entity within Greengrass. Each Greengrass group needs to have at least one core, one Greengrass core, and we can also define loggers, resources, and connectors, and then attach them to the Greengrass group. And once we run this CloudFormation stack, and we can also run this directly from the device, we can provision all the cloud resources that we need for our new device, our new thing being installed. This means that we can complete the first part of the architecture, and then we can have the other standard services such as machine learning and REST services benefit from the data coming from edge devices. Let me wrap up about the what we have discussed so far. Then we have no currently best one-size-fits-all solution for device provisioning. We have different approaches, and each one of them needs to be considered in the light of your context, of the number of devices that you are supporting. Ansible could be an enabling technology because you can put all the device provisioning, then IoT provisioning, invoking the IoT vending machine, and then the Greengrass run part within an Ansible call. So you can have your provisioning container in your local network, or even directly, some part of the container, even directly on the device. We have been able to manage just one thing set up and then make that core able to provision the other things as soon as they are switched on into the customer's network. And getting a certificate could be achieved using certificate vending machine architecture, which is so far, in my opinion, one of the best architecture that you can implement to have full control of certificate delivering. And we have been able to script that with CDK with a very few line of codes. Then Greengrass provisioning can be done through CDK, even from a controller or the device itself. And Greengrass is really a game changer because you can deploy the code directly to the device. Then I suggest you to start with a bare OS and configure other containers into your devices to be deployed by Greengrass. Here I can leave you a few resources, especially two projects which are really great. The first one is from Nathan Glover. It is AWS Greengrass, and the second one is directly from AWS Labs, and it is a reference implementation of IoT certificate vending machine. It is not CDK. We managed to use that as a reference architecture, and then we re-implemented that with CDK. And I plan to release the component in the near future to be able to allow that to be used by the community, and then the Greengrass missing manual. And so you can find and download the slides. And I want to thank you for your time. I think I've been just right with times.
Yeah, absolutely. Down to the minute almost. So thank you so much, Luca. That was a great, great talk, great timing. I think also a lot of great knowledge about IoT, right? So I like especially that part. That's always good for to learn about. So thanks a lot for the talk. It was great. And Eric.
Hey, Merrick, did you see the serverless in there? Did you
see
the serverless? Yes, okay. I'm just calling it out, Luca. I really was excited to see that. That made me very excited. Did a little happy dance. Boy, nobody wants to see that, though. So great presentation. So I appreciate it. So next, we are going to move on, and we're going to add in Thorsten. Thorsten's going to be joining us. Thorsten, welcome.
Welcome.
So, all right. He's going to be doing a live presentation. He is going to be talking about, and one of the things that I get a lot of questions on is, how do I go multi-account? All right, so I've got this working, but how do we go to multi-accounts? How do we go to multiple environments, I guess is another way to say that. So with that, I'm going to turn it over to you to school us on that. And off you go.
Yeah, thanks. So as you said, I will talk about multi-account and multi-region. So how to deploy your CDK application to multiple environments. Because as we all know, some people have test environments, all have production environments. And we want to have test environments, so we definitely want to put them to different accounts, different regions, to reduce blast radius. So who am I? I talked about this earlier, but just for a recap. So I'm CEO and cloud evangelist at Timos, which is my own company. I'm an AWS hero and CDK contributor. You can find me on Twitter. The Twitter handle will be in the lower right corner all the time, so you can find me all the time. So what do we want to do? So we will build a serverless API using AWS HTTP API gateway, but okay, it will already be there. This will be our starting point. And then we will deploy to different regions and to different AWS accounts, and even sprinkle in a little bit of testing in our pipeline. So how does this look like? This is our account setup. So we have our organization root. We have our organizational units like deployments, where we would have our CI/CD account, which is holding the pipeline. We have our workloads OU, which has our pre-production and production environments with our dev and prod. And Eric will love it. It's a serverless application. And we have our organization root account just for the sake of it. If you want to create these diagrams, I have written a tool called AWS Orchograph that's creating these diagrams for you. So let's dive into the code. So we have our, and it's the same all the time. Whoa, that's a little big. So we have our CDK application. As we all know, we have our app file. Our app file has this, implements our stack. Our stack then says, okay, please deploy into this account in this region. I'm a big fan of always specifying this so I cannot accidentally put it somewhere else. And our serverless demo stack is then in the lib folder. In this case, I'm using a TypeScript application. So we have a new DynamoDB table. We have an HTTP API. And we have Lambda functions. I'm using the Node.js function construct here. So it's automatically wrapping and building the TypeScript stuff with parcel and all the things. So I'm adding a route for tasks with a post, and I'm adding a route for task with get. This doesn't matter really because it's just an application we already have. So this talk will be about spreading it into multiple accounts. So we have an application. What's important for now, because all I'm talking about is in developer preview and not DA yet. So lookups do not work currently in a fully supported manner. So we should not use VPC lookups, hosted zone lookups, but always things that are in our application. But everything else is perfectly fine. So standard thing would be, okay, let's do a CDK synthesize. And then we will get our template for exactly this little serverless application. And the demo gods will show if this works. Because it's spinning up Docker in the background, using parcel and creating all these things. So what we now want to do is add more libraries because we want to build a pipeline. So what we need to add here is the CDK pipelines package. So there's a pipelines package that packages everything we need for the pipelines. It uses code pipelines, code build, and all these things. We just need code, the pipelines package here. What we're then doing is we import all the things we need in our application file. So our only thing we will be hitting is our application file, because we will not change our application, because this is fine as it is, but change the deployment of it. So we're adding imports of the pipelines, the code pipeline, and the code pipeline actions. So next to it, we will create a new stack. And this will be our only stack that we deploy in our application. Everything else will be then be deployed by our pipeline. So we go ahead, create a new pipeline stack. And in this pipeline stack, with all the code pipelines, we need to define some artifacts. So we'll have source artifact and a cloud assembly artifact. The source artifact will hold the source code coming from GitHub in my case, and the cloud assembly artifact will then hold the synthesized CDK out folder. So, and the next thing we're doing is creating a CDK pipeline. I will first paste it in, and then walk through line by line. So we're creating a new CDK pipeline from the pipelines package. We will give it a name, and we will provide the Cloud Assembly artifact that it should use between the stages. We have to define a source action. So where is the source code coming from? In this case, I'm saying, okay, it's a GitHub source action with all the things I need for this. So the owner and the repo and the branch. And then we define the auth token coming from Secrets Manager that's having our personal access token for GitHub. And it's outputting to our source artifact. And then instead of specifying all the steps manually, this CDK pipeline construct has something called a synth action, where we then add the simple synthesize action and using a standard NPM synth, because we're using NPM in this case. We're providing the source artifact and the Cloud Assembly artifact. So it knows where to find the sources and where to put the assembly. In my case, we're overriding the install command because we don't need only npm CI to get our package there, but in the Lambda folder, we have our Lambdas with their own package JSON, so we need an npm CI for this folder too. And as we might need Docker, I use a privileged container. So the moment we do this, we have our first pipeline defined. It's just a pipeline, it's not doing anything. It's just building everything, preparing everything, but not deploying anything. And for this to work, first of all, we need to remove this part. We're not deploying our application anymore using CDK directly, but we're now, instead of this, adding our pipeline stack to our application. So we have a new pipeline stack with everything we need. It's the same account, same region. It's just deploying the pipeline instead of our application. Our build finished, so we can see what happened before. So before it was just our template of our application. And in the next step, this will be different. So if we now would deploy this, I'm just going to the code. If we deploy this, it looks like this. So it deploys a pipeline, which has a source. It has a build phase. In this build phase, it spins up. It spins up a code build. And in this code build, it will do the CDK synthesize, and it will prepare all the assets. And in the next phase, it will start a code build project and self-update the pipeline. So whenever we change the pipeline, the first step will be deploying the pipeline stack. And if the pipeline stack changes, restarting the whole pipeline. So when we add new stages and change things to the assets, it will always self-mutate the pipeline and then deploy everything else. So now we need to create something called a stage. So up there, we are adding something, extending the stage. We're calling it app stage. And in this stage, we're now instantiating our serverless demo stack, which was our application before. So we just moved it into this stage, and that's all we need for this application to be there. And for our pipeline, we then add stages, which is just pipeline add application stage. And then we instantiate our stage, which has the pipeline as a parent, a name, and an environment where to put this stage. So in this account, in this region, as you can see, one is in Frankfurt and one is in Dublin. That's why I named it differently, and it will prepend this to the stack name. So, and if we then deploy this, we get another setup. So if I go to code pipeline, we now have the source, the build, the update pipeline. Then there was there is a new code build project called assets, because it will then upload the assets to the S3 buckets in the desired accounts. So it is an extra step deploying all your assets. So in this case, the Lambda zip folder. And then it's deploying or creating the stage for my Frankfurt deployment. And it's using the native CloudFormation change set and execute change set actions in code pipeline. So I'm not paying some code build project to deploy some things in CloudFormation. And then it's the same for our Dublin account. So this is multi-region with just one line, and I can just put there more and more and more for more regions. It's just working. It will redeploy the pipeline and then redeploy your application. So now we want to add some tests. So in our app stage, we need to do some minor changes. So first of all, we're declaring some outputs here. And then we're just using these outputs here. So what I'm now doing, I'm creating new CFN outputs in my stack based on the table and the API and put them into variables in my stage. That's everything. So now I have these outputs. First of all, I can see them in a concrete execution. So if I go to an execution and look at the deployment, I can see them as the output variables. But the even better part, I can now change a little bit. Namely, I will remove this and replace it with something similar. So it just extracted the app stage to a new variable to be able to then do some interesting things here. Because now for this stage, it was just creating a change set and deploying the change set. It's now adding a new action called a shell script action. And this shell script action has a name, as everything in code pipeline, and it has commands. And these commands will be executed using this code build project. And I can use environment variables, in this case URL. And with specifying use outputs, I can populate these environment variables as stack outputs. So what's happening here is that the API output I defined in my stage will be put into the environment variable for this code build task to validate or run these commands. So if I go back to my pipeline, so I added this to the Dublin pipeline, there's a new action here called validate dev Dublin, and it's a code build. And if I go to details, I can see the build log. And the build log now says, okay, I'm doing a curl somewhere, and this curl is going to this API, and it's doing stuff, and it's doing things, and it's certifying because I'm using curl verbose, and it has my output. So everything's working. And I can do some tests here, and if everything's fine, I transition to the next stage. Otherwise, I block the stage and the run. So I can do automated testing of these deployments. And now comes the hard part. I want to put it into another account. And for this really hard thing to be possible, I add another stage and specify a different account ID. And that's it. Because it's nearly it. So it's everything I need to do for this stage. What I had to do beforehand, so it's always the secret magic, I had to bootstrap my accounts using the new CDK bootstrapping experience. It's documented on the pipelines package. And for this to be allowed, I had to specify in my second account that it should trust my CI/CD account. And that's why you definitely should go to this reference architecture, having a CI/CD account and then multiple stage accounts. And each of these stage accounts will then trust your CI/CD account. So everything running in your CI/CD account, especially the code pipeline, is allowed to assume the CDK roles in your target accounts and deploy things there. So that's everything you need to do for the multi-account stuff. It's just adding it here. And then in code pipeline, it looks like, okay, there's a new stage. In this case, I decided, just to show that it's possible, to add multiple state environments in one stage. So not one prod Frankfurt, prod Dublin, but in one. However you like it. You could even put it in parallel to speed up the deployment into multiple production environments. So the really interesting thing is to bootstrap your account or your accounts correctly using the new bootstrap experience and the trust relationship to your CI/CD account, and then the rest just works. So for that part for the production. So there are blog posts. So if you look at the AWS CDK, I can show you one thing where you can find more of these. And so it's in the packages. And then there is this pipelines. I cannot emphasize it enough. It's developer preview. So be aware. I would not say don't use it in production because I'm using it in production, but you should not do it. And there is everything laid out again. And the things you need to, when provisioning your account. So bootstrapping the accounts is really important that you do this with a new experience and across account trust. And then everything just works because the new bootstrapping experience will deploy IAM roles with given names that can be determined by other accounts because they follow a specific schema. And then they can be assumed across accounts and then deployed using code pipeline. Important thing to notice, there is in code pipeline, there's this details button to go directly to the code build project or the CloudFormation deployment. This does not work for cross-account deployments because it's a deep link on the web console and it's now deep linking into CloudFormation in the CI/CD account and not inside the target account. So this is something that's not working. You have to switch to your target account and go to CloudFormation there. So it's not something you do wrong. It's just not working like this. So let's see what's happening in behind the scenes. So there are many stacks deployed here. So first of all, in your CI/CD account, in this case, Essential, because that's where I deployed my account, there's a pipeline stack being deployed. It then deploys my dev Frankfurt and my prod Frankfurt in the dev and prod account in the same region. It also deploys the Dublin stacks in the Dublin region. And for this to be possible, under the hood, you don't see it, but it just is there. It deploys a support stack in the CI/CD account in your other regions. So in all regions where you deploy your application, there will be a support stack. And because it needs to create a new bucket for the assets for this region, because for Lambda, for example, assets have to be in the same region. And it sets up bucket replication so that all assets are in all regions for the deployment to be there. It's the same for the CloudFormation templates and so on. So this is definitely something you should know that is happening, but you don't have to worry about it. What you might need to worry about if this is just for testing, for this to work, so everything is encrypted by default. So all the buckets are encrypted with CDK bootstrapping. And because you need cross-account access, encryption only works with customer-managed customer master keys and not with AWS-managed customer master keys. And because of these CMC in the case, you have to have your own keys, and they cost $1 a month, I think, per bootstrapped region and account. So this is something you have to keep in mind. It doesn't matter for, I think enterprise setups or some setups where you deploy real workloads, but if you do it just for fun, maybe not deploy to 22 regions. So that's it for the stacks that are deployed. One very important thing is, if you change something to the pipeline, or if you create the pipeline the first time, and for the first time for the bootstrapping, you have to do it using CDK deploy. And further on, you should not use CDK deploy, but using the pipeline itself to self-mutate. It's very important to push your actual code to your repo, and then if you then put it once to the repo, then you can do your manual deployment, because the pipeline will start immediately when it's created. It will check out the current state of the repository and self-mutate to whatever is in the repo. So you should make sure that the current state is in the repo before you do a local deployment. So that's it for my presentation. I think we can do a short Q&A after this. So definitely visit the AWS CDK GitHub and give your feedback on all these pipeline features, because they're still under active development. There's room for comments and things that can be done. I've written a blog post for creating a CI/CD pipeline for your CDK app. You can find it on my webpage, timers.de/blog, or on Dev, on the Heroes AWS Heroes group. Little self-plug, I provide coaching for CDK, and you can find all my GitHub things with all the CDK demos and all this org graph and some tooling I'm writing under my GitHub/Timers. So that's it, and yeah, open for questions.
All right. Hey, sorry, Matt, I jumped first. I got it. Hey, Thorsten, there's a couple of questions real quick, and I thought I might throw it here. So each account gets a customer-managed KMS key. Is that correct?
Each account and each region that you bootstrap with the new Bootstrap experience gets a customer-managed customer master key, so CMCMK.
Alrighty.
This is needed for cross-account deployments. If you don't need cross-account deployments, okay, then you're not in my talk right now. But that if you don't need cross-account deployments, there is a current pull request open to disable customer-managed custom master keys to remove the cost. But it's $1 per account, so you definitely have $1 per account and region.
Alrighty. We have another question from Brian. What are the gotchas, pain points for dev iterations for defining the pipelines?
So for the development of the pipeline itself, it takes a little while, because you always have to put it into GitHub, and then it goes through the pipeline self-mutation and so on. There's another open pull request for this to stop self-mutation for development purposes, and then doing CDK deploy for every change manually. And say, okay, I'm just updating the pipeline whenever I like it. And if I'm fine with it, then I do another deploy that's reactivating self-mutation and go back to production mode.
All right, excellent. So one other one we have in here is, so the CDK role, is it something that you'd have to set up front?
You just have to do the CDK bootstrapping. And if it's not the right version of bootstrapping, it will tell you, please update to the latest version of bootstrapping. And with the latest bootstrap version, it will create cross-account roles for deployment, for asset uploads, for repo pulling. So I think it's 3 or 4 IAM roles per account and region. And they have a specific pattern like CDK, some kind of random string, but it's not. So it's a random looking string, but it's the same for all accounts, and the account ID at the region. So CDK knows how the role in all the other accounts is called.
All right, excellent. That's all the questions I'm seeing. Matt, do you see any others?
Yeah, we had a couple over from Slack. So, Thorsten, would you have any recommendations about how to best, especially within the case of these pipelines, divide up stacks? Does everything go in one stack? Should you have different stacks? How would you approach it?
So to keep it simple in the beginning, I would start with one stack per environment, because having multiple stacks for different environments is crazy enough for the beginning. And if you see some things where you might hit limits, which is especially in the serverless case, might happen fast if you build one Lambda per endpoint for an API gateway, for example, and you have a role and all these things coming up, you might hit the 200 resources limit pretty fast. So then that's where I start to break it down into more stacks, like, okay, this part of the service is going to one stack. And so one is for the API, then one is for this part of the Lambdas, one is for this part of the Lambdas, and so on. But this is something that could be done inside your application stack. So you can have one stack for your real application and do everything inside this application. So in your stage, you can vary for a long time. You can stick to one stack here, or at least one construct here.
Gotcha. And any advice for anyone who's looking to adopt pipelines, either rough edges or, gotchas that stuck you up originally that you would just recommend that they watch out for?
So one thing that's definitely, just as I said, not yet supported is lookups. So the moment you use context lookups like VPC lookups, hosted zone lookups, things like that, they're currently not working in all cases. So there is a way, if you do the lookup once locally, and the context JSON is there, it will use this context JSON instead of doing the lookup. So it works in some cases, but it's definitely a rough edge. And this is something that's being targeted for the GA that is working then.
Okay, so would a developer then be responsible for running those lookups locally and then committing that CDK context JSON file into
that? That would be a way for the time being, or just try to avoid these lookups. So that's why I demoed a serverless application, because then I don't need VPCs, and that's the main lookups I'm doing. Everything else could be done in the stack.
I would like to just say, you're welcome.
And if you deploy VPCs, you don't care about the KMS key costs because you have NAT gateway.
All right.
Indeed, it saves you a lot of money there. Yeah. Well, good deal. Well, thank you very much, Thorsten. We really appreciate it.
Yeah. Thanks.
All right, so we're going to move in. I'm going to share another screen here. We're going to move into our next conversation, our next session, which is a lightning session. The good, the bad, and the ugly of CDK. CDK adoption in a big enterprise by Matt Jovanovic, and I really hope I'm saying that right.
I think it's Jovanovic.
Okay,
we'll see which one of us is right.
Yeah, names. No, I barely pronounce my name. I have, just so you know, I have 5 kids, and I would, if I could today go back, I would change their names to 1, 2, 3, 4, and 5, just for that reason. That would be much easier. All right, with that, we'll pass you on to Matt.
Hello, everyone, and welcome. I hope you're enjoying the CDK day. I hope you learned a lot and saw a few interesting sessions in the previous hours. And thanks for sticking around. So I'm Matt Jovanovic. You can follow me on Twitter. And today I'll be talking to you about the CDK adoption in a big enterprise. The good and the bad about it. Actually, the good, the bad, and the ugly about it. So without further ado, let's get started. So I work at CEPSA. CEPSA is based in Spain. It's an energy company. So we bring energy options and energy solutions to people. These are our BUs you can see in the screen: exploration, production, refining, chemicals, and all that other stuff. So we have around 10,000 deployees all over the world, on all the continents, and we are quite big on AWS. So we have all our data lakes. Most of our application stack is serverless, so we went cloud native all in. So today we have over 100 AWS accounts. We are mostly using cloud native and serverless, and around 5,500 CloudFormation stacks. So just imagine any migration to any other tool for us would be a nightmare. So talking about development teams, that's the complex part about big enterprise. We have 3 different types of development teams. So the first one is in the area of what we call digital transformation. These are the most innovation-oriented data engineers and scientists, and they have this product orientation. So they build and run their own products. So that's a really good progress from the traditional IT, where we have internal teams developing an application and then just handing it over to the IT ops, which would be our second model. And then we have the third model, which is external collaboration. So we have a bunch of solutions that, due to skills or expertise, we prefer to outsource the development. And the challenge of that part is that later it comes back to us like a boomerang. So regardless of the other company developing it, we are the ones who have to end up operating it. So CDK is something that I had my eye on for a while. As I'm leading the Cloud Center of Excellence in CEPSA, I work as head of cloud. My team is always looking out for innovation and new solutions in AWS. So when we saw CDK, we really liked it, but we have a really complex environment. So multi-region, multi-account, authentication is pretty complex. We now use AWS SSO, which is amazing, but it didn't used to have API. So once it started supporting native integration with the ADFS, which is our identity, we started using it, and that was really forward. But when it comes to authentication and MFA in a CLI, then it becomes challenging. So what happened to me in the beginning of this year, I got this guy. So in Spain, that means that you get 3 months off to help the mother and program, right? Because I've been focusing quite a lot on management recently. Leading teams is not easy. So I missed programming. So I said, okay, I'll use my paternity leave, 3 months, to take care of the baby and also test CDK. See if it can really fit in a big enterprise. See what challenges I find in documentation and everything. So I took this approach. So on matchcloud.com, you can see all this because I like open source community. I like the community. That's one of my favorite things about CDK. So I said this, okay, so I'll take this real enterprise type serverless application, a type that we use in CEPSA a lot, with Cognito for authentication, federated with whatever, CloudFront as CDN, application load balancer, then for static content images as such as S3, for a container where the app would be running, constructing the IAM service policy so that the container can access Dynamo and whatever else it needs to access in the backend. And I said, okay, I'll document this. I'll work on a workshop, and when I come back from my paternity leave, if this works, I'll show it to all developers, and we'll see if they like it. So on the web, as you can see, on matchcloud.com, you can see all this. So you can go to Become a Cloud Ninja if you're interested, and go to Cloud Infrastructure. And here you can find, like, you see CloudFormation, CDK, IAM, Cognito. Everything is fully documented as a workshop. So you can run through it and learn how to build the real CDK enterprise application. So Cognito, like what Cognito is, what we're building from the architecture you saw before, requirements, code, how it all should run, then also some problems, how to configure the domain names in Route 53, certificates, everything that you need for a web, and then also some problems that you can run into and how to solve it. I'm particularly proud of this part. So back to our PowerPoint. I built all this and I was amazed. So I said, okay, coming back from my paternity leave, I'm going to present it to the guys and let's see what comes out of this. So the first part was the developers. We went as a center of excellence to talk to them, and we presented all this. Like, you can do infrastructure of AWS in Python or TypeScript, or this is how it works, and they just loved it. It was so easy. We just said, okay, so you can start using it, but wait a bit. We need to check with the operations if they're happy about it, because the developers were such an easy sell that it was almost scary. So we went to our SRE team. So SRE are real ninjas in SAAS. So they have this thing, this weapon, this shield that's called production ready, and that's the set of rules and tools and a full checklist of what a new service or application needs to develop, to include, in order to be received on our part. So they go around, talk to the production teams, product teams, and they help them build this. But this shield is really strong for them. That's their only weapon, so they take really good care of them. And just imagine day to day for them. It's a bunch of companies coming from all sorts of different proposals. Terraform, I work with VMs, no serverless, OpenShift, Kubernetes, and then like Lambda, TypeScript, Golang, people who now just do Java. They really need to be strict about that stuff. So when we presented CDK, first answer was no. TypeScript, no, we're not doing TypeScript. And we had to sit down with them, explain the point, and they quickly got it, because these guys are hardcore software engineers with a lot of experience, but they know that when the lights go off, they call them. So it was easy. You can see now the happy SRE, happy Captain America, because we decided to just allow CDK with Python to document everything properly, and that was all happy. Everyone was happy. So that was the bad turned into good. And then we got to the part that was ugly. So when we started talking to traditional operations, so the guys who handle like networking, operating systems, who install Windows and stuff like that, who need to change security groups and routes sometimes. So they do that in CloudFormation, they accepted that. But when we told them that they need to operate stuff in Python, guys who never programmed, that was a hard sell. That was a really hard.
All right, so not exactly sure what's going.
They know that in Python they don't have enough control as they do in the console to quickly change something. And this workaround, this is what took us the biggest amount of time. So my advice to all of you, if you're looking into CDK, think about this part. Think whether it makes sense to teach your operations everything they need to know to do CDK. How we solved this is that we reinforced production ready a bit. So we included just Python in CDK and a set of rules, naming, tags, everything that need to exist for the developers. So they were happy. These are rules that are documented, it's okay. And on the other side, between Cloud Center of Excellence and SRE, we organized intense workshops to teach IT Ops Python, mostly Python, and then CDK, because once they learned all that, they got on board more or less easily. So to conclude the presentation and the session, it wasn't really that ugly once we really understood what's going on. So thank you everyone for your attention. Follow me on Twitter. I'll be on Slack for the live Q&A, and I really hope you enjoyed the CDK day. Bye-bye.
All right. Well, I don't know what that little pause was there for a moment, but, one glitch in 5 hours sure isn't too bad. So really cool hearing about, some of these larger enterprise adoptions, because that's a question that always comes up in a lot of the forums and things like that. So, Merrick, what do we got next?
Yeah, absolutely. So we have a very interesting talk actually coming up. You already see it a little bit on the logo. So Andreas is actually going to be talking about how he is building and prototyping CDK for Azure. So, you've seen already throughout the day, of course, that there's various flavors of CDK. There's kind of the vanilla CDK, right? That was started before. There's CD skates, right, for Kubernetes. But people are even taking it to the next level and trying to integrate this, for example, with Azure. So I'm actually personally very excited for this talk, very curious how that's working and how that innovation is happening. So yeah, I suggest we hand it over to Andreas. Enjoy.
Welcome, everyone, and thanks for attending this talk at CDK Day 2020. I am Andreas Heumaier, Senior Engineering Lead at a group called Commercial Software Engineering at Microsoft, and I want to highlight a project I did lately called ArmKit. This is a quick story of how to prototype a CDK for Azure. But let's begin at the start. I have an ongoing discussion on cloud infrastructure as code for some years now with a friend of mine who's working at the Terraform CDK these days. And having had this journey myself for years using cloud DSLs from Toposphere to even end up building my own in Ruby ARMKit v1, one reoccurring weakness I felt in all was they are rebuilding the cloud provider's API objects instead of directly generating them using their own definitions. So they were always too late on the new stuff or getting unstable in adapting too fast. Another one is I barely found any testing frameworks in place which could keep up on the ever-changing tooling, or they are being so simple that it feels like building the framework from scratch again. And then there was CDKs coming up, promising more, and there was the question about Azure. We didn't find a proper approach so far, so we just thought we started ourselves. And next up, I want to outline in a few slides the principles to get going and what we learned so far from it. So where to start? We start with the JSON schema. Most providers have one where they describe their API resource objects. Let's take a look. Here we see an example of the Azure schema root. All services and resources with their different versions are cross-referenced in subdocuments from here. And this is a source of truth we need to build our CDK code on. Once we have the resource schemas located, in the next step was unifying the scattered pieces with all the relative and absolute references in it as one. Using JSON schema ref, we walked through the root schema from the start and expanded all reference docs and subdocuments. We replaced all relative references with absolute file path so we can use them properly for translation later, as shown in the example of the data factory identity resource below. Think we're missing something in the example as shown below. Definition JSON expression is a global catch-all allowing type expressions to the schema, meaning if it's not a defined resource here, it's a regard defined somewhere else. This is more like a fallback, and we don't need to replace that. Having a full resolve schema, with absolute references, we are ready to start translating the schema to TypeScript using awesome GSII CodeMaker. We're just standing on the shoulders of AWS CDK, Kubernetes CDK, and others. We took one resource scope, a 3-node, as a class and iterating over all resource types and resources and types in it, writing out one after another. This leaves us with TypeScript classes describing the resource and types we took from the schema, shown previously as an example from the data factory identity. Having this one large resolve schema in front of us to translate, we found large schemas are not necessarily fully consistent in its structure, so there was still a lot of bumpers on the road for us. Instead of trying to resolve all of them at once, we decided it would be faster to splice the fish, and introducing configurable schemas parts from the root schema shown previously, which are way easier to back and prefix in a smaller scope. Successfully resolved this, we are able to build now our first construct. The hello world in the world of CDKs is simple storage account. We see the import of all the packages and all the modules needed to implement a storage blob named MyStorage452442 KDA in West Europe. On the last line in the example, we instantiate and run the newly defined hello world ARMKit using CDK out, the target file for our template code. We take a look at the CDK out file. we see the generated ARM template JSON now. With my storage in West Europe has been properly generated and it's ready to deploy. Of course, AZ CLI validate would help us on validation to make sure we are right here. For those about start building right away, here are some words on caution. We are just about starting. This is just a first step to demonstrate how to start with a CDK-like approach on Azure. This is incomplete in translating the whole schema yet. We missing the full test suite and a construct library, and we are still working on having multi-language support for or using with GSII. So we need and looking for your help, ideas, and support to make this fully functional and to our goal to get this accepted as an Azure open source software project. Please create this with us. With the next slide, I want to give a short glimpse of what I'm looking for in the future of not just the Azure CDKs and what could be on even tomorrow. Since providing a CDK not just for Azure but for all cloud tool providers is open up major opportunities. We could be able to unify an infrastructure platform approach at native languages, describing cloud infrastructure, including other service platforms like Azure DevOps, Kubernetes, and others, in one native language like Python or TypeScript, and or simply adding your small helpers directly to the infrastructure code. Drive testing strategy. This is one of my major topics, as they are used in programming languages. I want to reuse my testing frameworks I have for native languages to test my infrastructure, to provide the right scopes and tooling around that, and generating tests from my infrastructure code before deployment and reuse them later if I change something. Rely on a single construct used on multiple platforms, building generalizable objects. These are big dreams so far, but we have native language interfaces now, so it's a developer's world again. Interoperability on different tools using the same language. For example, generating ARM templates or Terraform combining ARMKit and CDKTF opens up a lot of possibilities. With this, thank you for watching, and if you feel like you want to get your feet wet in helping building the Azure CDK, reach out to me directly or come contribute at GitHub, JetX, ARMKit, and thank you very, very much.
All right, we are back, and I couldn't do this without bringing Sam into the mix. I'm sorry, Matt, you told me absolutely not. But I did it. I couldn't help it. Sam was here too. We all work along to build serverless, to build applications. So what a great day. Very honestly, what a great day with CDK. Some incredible presentations, some very few glitches, but some, it happens. You know, sometimes we chat publicly when we mean privately. Sometimes we, you know, files get paused, whatever, you know. So they happen, and there we go. But we really appreciate this day. Matt, I'm going to turn it over to you. Matt Coulter, I'm going to turn it over to you for a minute and just to say what this is the guy who kind of arranged all this, so I'm putting it this way.
Yeah, so I mean, from my perspective, listen, my goal was let's bring the community together. Let's all talk about CDK. Let's talk about the many CDKs as opposed to just one. And let's all get into one communication channel as opposed to we were in, I don't know, 50 or 60 before, whereas I saw the comments, there's over 600 people now using the CDK.dev Slack channel.
Yep.
So I've really enjoyed all of the presentations. I know we had some issues, but this was our first go. We pulled it together really quickly. So I've loved every bit of this, and thanks everybody involved.
Yeah, agreed. Thank you, everybody, all the volunteers that were active in the Slack channels, all the presenters. We obviously could not have done this without you. So thank every one of you for putting together those presentations, giving them really helpful. We had a ton of submissions, and we actually had to whittle down a lot. So, there's a huge effort within the community, and it's fantastic to see. So thank you, everybody. Thank you, EJ, and thank you, AWS, for helping us put this on. We really appreciate it. It's been fantastic working with you. So thank you.
With that, we're going to sign off on the world's very first CDK day, and we appreciate it.
Whoa.
Yeah, have you not thought of it that way? So we appreciate it.
Yeah, it's history, right? It's history.
That's history.
We can say we were there for the first one. Yeah,
that's right.
Yeah.
All right.
If you and if you like more about CDK, think about joining the CDK Happy Hour. So that's definitely something we wanted. We started in August. We skipped the September one because of CDK Day, but we're doing this monthly. So we will have a CDK Happy Hour. It's a global one. The DE is just because Meetup needs a location, but it's not a location because currently we have no locations. We have remote, so it's a global CDK Happy Hour. Join us, and we will announce the next event soon.
Thank you, everybody.
Thanks all.
Thank you.
Have a great day.
Thank you.